Hi, good morning, good afternoon, or good evening. Of course, it depends where in the world you are. Welcome back at day 2 of the Global Azure Bootcamp, the virtual edition. So it truly is a global community. We have over 200 speakers worldwide, over 300 hours of Azure content going on, started yesterday, today, and of course, we also have a third day tomorrow. My name is Isidora Katanic, and I'm calling in from Switzerland to be your virtual hostess today. But of course, I'm not doing this alone. We have in the green room today, we have Carl Otts from Finland and Alex Monk from Romania. And I have a fantastic co-host today who, of course, again looks absolutely fabulous. We have Rick Hepworth. Say hello.
Izzy, you say the nicest things. Yes, hi, I'm Rick Hepworth. I am an Azure MVP, and I'm coming to you from sunny Yorkshire in the United Kingdom.
Awesome to have you here, Rick. Well, so of course, today we have the feature track in the next couple of hours, and we have a lot of community content going on. And I'm sure you're thinking, where do I find all the information? Where do I find which sessions I can watch? Which speakers are presenting? So maybe, Rick, you could pull up the website and quickly walk us through the agenda.
I can. Let me just share my screen so that Alex in the green room can switch to it. So the place to go for all of the information is our website, which is virtual.globalazure.net. And you can see on the homepage that I'm showing you now, we've got now 233 speakers, 305 sessions. And I know that we're still adding more, which is absolutely fantastic. So if you want to find out more about the featured stream, the one that Izzy and I are presenting today and tomorrow, if you go to featured speakers, the agenda for today is there. In just under 10 minutes, we have the marvelous Brenda Burns, who's a corporate vice president at Microsoft now, and one of the co-creators of Kubernetes. And later on, we've got Mark Fussell, who's Mr. Service Fabric, and Natalia is bringing pretty much the entire Azure Stack team, I think, to talk to us later on, isn't she? She is.
Yeah, that's going to be fun. Absolutely.
But those speakers aren't the only ones involved in the event. Right now, across the world, hundreds of people are making content available for you, the viewers. And if you look at featured speakers, you'll be able to see their bios and see what sessions they're doing. Just pick a face, click on Aiden because he's a nice guy, tells you the speaker, gives you their social media details so you can follow them, and gives you a list of the sessions that they're going to present. If you click on that session, it'll take you to the session details. Another way to get to those, though, is if you go to the worldwide sessions list, we have every single session across all 3 days. We automatically take into account your time zone. So those times that are being displayed on that website are local to you. Should you want to, just up here, you can change the time zone so you can see that it's displaying Europe, London for me. And also there's a little tick box underneath, hide sessions when they've ended. By default, we're going to show you content that's going on now and upcoming content. But all of yesterday, there were some great sessions on there. So if you untick that box, it'll show you many great sessions that you can go back to. Now, to join a stream for a session today, just click that big yellow button. It'll take you straight to the link that the speaker provides. For sessions that have finished, we're encouraging speakers to tweet out and post on social media where the recordings are available. Obviously, if it's a YouTube link, then you can go straight there, and generally the recording is there. It'll vary from session to session. Please be patient with our speakers, and please be nice to them. Not all of our speakers are able to make those recordings available, so you know, don't get the pitchforks out if they don't. Yeah. Anyway, enough about the website. Because I've got my browser shared, I do just want to call attention. Over the past couple of days, Izzy and I have been tweeting out, asking you to tweet our Global Azure mug hashtag. I think Izzy might win the day there with that Azure mug. That's even better than my Jedi mug. Have a look on Twitter. Lots of us have been posting with the hashtag Global Azure mug. There's a couple, though, that I want to call out today. First of all, I want to call out Chris, because Chris is going to be with us later on this afternoon. He's going to join us with the Azure Stack team. And that's an awesome photo of a very gregarious chap there with his mug. And we'd also like to call out this one from Karthik, because we thought that the slogan on that mug was just awesome. And it's really great that Milton Keynes Azure User Group are getting involved and promoting Global Azure. So hi to Karthik from Izzy and I. And with that, I'm going to throw it back to you, Izzy, to tell us a little bit more about what's going on today.
Yeah, awesome. Thank you so much for sharing the photos. So make sure you are tweeting that you are active today, as well as tomorrow, of course, under hashtag Global Azure. And if you want to share your mug, like I've just showed you mine, then make sure you tweet that out using hashtag Global Azure Mug, and we might feature you in the next couple of days here on our track today. So, are we ready for our first session, Rick?
I believe we may be. We've been joined on the call by Brendan Burns. So Brendan, hi, thank you for joining us today. For those of you who aren't aware, Brendan is corporate vice president now at Microsoft. In a former life, he was at Google and was one of the principal engineers involved in the creation of Kubernetes. And I suspect, to be fair, that questions about containers in Kubernetes are going to make up the bulk of the next 45 minutes. But whilst we've got questions that we prepared ourselves just to make sure we're not talking dead air and we've got something to keep Brendan occupied, we'd really welcome you watching the stream. If you look at our YouTube chat channel, if you can paste questions in there, we'll do our best to relay those to Brendan. He's armed and dangerous with a whiteboard today, and
yeah, I've been doing a lot of engineering for a long time, I guess, at this point. I started, I went into graduate school and got a PhD in robotics, actually. So I spent about 7 years of my life messing around with robots. Actually, you can't see it, but in another corner of the basement, there's a robot over there, which is fun. Actually, a couple. I have a couple. They're old. Like they were old when I left graduate school, so that's anyway. I worked on, as was mentioned, I worked at Google on web search, and then on cloud, and started the Kubernetes project now. Gosh, it was close to 7 years ago, which is kind of remarkable. Came over. I'm from Seattle. Grew up in Seattle, and so coming to Microsoft was really a natural home for me. And have been focused on a bunch of different things actually since coming to Microsoft, including the Azure Resource Manager, and policy and governance, and thinking about how people manage and deploy their applications and their life cycle of their applications into Azure. Obviously the Kubernetes service, also generally Linux on Azure and open source applications on Azure. And lately as well, the Service Fabric teams and the SAP teams. So pretty broad portfolio. I'm happy to actually answer questions on any of that. And I did bring a whiteboard, so I'm going to, if the questions are apt for screen sharing and whiteboarding, that is the medium that I like to do. So I was a professor for a couple of years. I guess I didn't mention that. I was a college professor for a couple of years. So I miss being up at the whiteboard. So this is an opportunity to do that. So hopefully it's enjoyable. So
we love whiteboard sessions too, because we love that whole dialogue and visual explanations. So
yeah.
Brendan, I've got the questions in front of me that we sent to start you off. Shall we kick off with some of those and get you flexing your whiteboard muscles, and we'll see if people post questions in the stream as we go forward?
Sure, sounds good. I just shared the whiteboard, so hopefully you can see that. There's not much.
Excellent. So no pressure for the first one. Will containers take over completely? And when they do, how will containers be easy for the straightforward use cases of cloud?
Yeah, it's an interesting question. It's something we think a lot about, actually. And that's because I think there's different things to think about, right? So I think that...
Sorry, Brenda, can I just interrupt a sec? Would you mind, could you minimize the little Skype window that's sitting over the top of the whiteboard?
How's that?
Brilliant, thank you. Sorry,
awesome.
Carry on.
Yeah, I know it's always embarrassing to see yourself broadcasted through your... Anyway. Yeah, so I think there's a bunch of different things to think about. It's like when we're talking about the container, we're talking about, so if we put a container here, there's different aspects to this. I think one of the aspects is actually just sort of the packaging. Oops, that's not, I didn't mean that. I didn't want a pentagon. One of the aspects is the packaging, which is sort of the box that we put and we push it around the world. So that might be the thing we push to the cloud, or it might be the thing that runs on a particular computer. Here's my computer. It's not a very good computer, but that's life. And I think that packaging, so the packaging of something as a container image is going to stay around. I don't see any reason why anyone will invent a new way of packaging up code or a new way of telling a machine or an orchestration system what to execute. The things that we have work pretty well. They have some nice characteristics. They were designed for particular things. We might refine them a little bit, but that idea of the container image is going to stick around forever, I think, and take over most computing. However, I think the thing is that most people aren't going to necessarily pay attention to that, right? Because the other side of this is, how does the person who's writing the code, how do they get their code into the container? And I think that's the area that can be hard. And that's also the area where the most work has to happen. And so you can imagine, you can provide, and we do actually provide today, an Azure Functions kind of experience where you can just give yourself a little snippet of code, and behind the scenes, this thing can get packaged as a container and it can run on Kubernetes. But from a developer perspective, you're just running serverless code, right? And there's event handlers that will activate. So there's some sort of queue, and items going into the queue will cause that function to run, right? So I think I would separate the question around, like, is containers going to take over everything, into the technical aspects of an execution environment and a format for a program to run. And I think that's just going to stick around because it's useful. It's a very useful abstraction. Versus the development environment or the programming model that a developer uses to build an application. And I think there you see a heterogeneity already between things like app services, Azure Functions, a whole bunch of other different models, either open source or in the cloud, around how do I get my code into a container. And I think that trend's going to continue. And I think it's going to go even beyond, because what I've focused on so far is, I'll clear this out. What I've focused on so far is individual containers, but the truth is that most applications are made up of lots of containers, usually from different sort of microservices. And the question of how does a developer create that, right? How do I describe this whole thing is even more complicated. And I think we're going to see tooling come and try and address that as well, because I think that not only is it hard to get your code inside of a container, it's also hard to express sort of how all of the services that make up your application come together. I'm hopeful. I mean, this is actually the most interesting problem I think we're working on, or certainly one of the most interesting problems we're working on right now. And we've got great people to talk to in like the .NET team and in dev generally, as well as in the open source communities. And so I expect over the next 5 years, if we spent the last sort of 5 to 7 years getting the Kubernetes infrastructure mostly finished, The next 5 to 7 years are going to be figuring out how we actually make it easy to build applications for it. So kind of long-winded, but hopefully an interesting answer. All right.
Okay. So I was expecting Izzy to chip in there, but
oh, sorry, yeah, absolutely. Here I am. Yeah, definitely. So thank you very much. So let's check what's the next question. So here's the question. There are concerns that AKS is too expensive for most small shops. Would you agree or disagree with that?
Well, I mean, yeah, I think at some level it is, because like the drop charge, I mean, the smallest cluster that you can run is probably about $100 a month, 100 US a month, which is pretty expensive. It's pretty expensive. I mean, it depends on what you do with it, right? I mean, you could be a web hosting shop or something like that, and you could put lots of applications. You know, if you have your three nodes, okay, 3 nodes in your cluster, you can put lots and lots and lots of containers on that cluster and sort of amortize the cost of, you know, that $100 across a bunch of different sites if you wanted to. But yeah, I mean, $100 is a lot, right? And so if we think about this being the Kubernetes API layer, you know, I think one of the things that we're really trying to do, and it's not done yet, but what we're trying to do is we're trying to take those machines, those VMs, and we're trying to delete them, and we're trying to replace them with serverless containers. And this is basically ACI, right? So this is the virtual nodes work that we have right now. And unfortunately, right now, because some of the ways that Kubernetes works, and some other details of how Azure load balancers work and some other stuff like that, right now you can't. When you have those virtual nodes, you still have to have a couple VMs. And so we're going to pretend that was a square. So you still have to have a couple of VMs even with virtual nodes, and so you still pay money. But I think as we go forward, we're going to get to a place where you can have pure serverless, right? We'll get rid of all of this, and so you only pay for the compute that you need and the compute that you use. And at that point, it becomes cheaper. Although I think one of the challenges that we always have is especially for sort of really small stuff, is that, you know, one of the things I always think about is like there's kind of 2 cases in the world. There's 0 to 1, and there's 1 to n. And paying IaaS pricing in the 0 to 1 case doesn't usually make sense, because your IaaS is idle most of the time, right? It's just sitting there. If I have a little speed gauge, it's just sitting there, you know, at 0%, and so you're paying money constantly for something that's not in use. And that's why, you know, an event-driven model like functions. So functions as a service, where when you're idle, you're just sleeping. That event-driven model makes a lot more sense at 0 to 1. Now, the funny thing is it flips around, right? So when you're in the 1 to n case, IaaS is actually, because you peg the CPU, IaaS is pretty cheap, and FAS, because you're paying for every request, is actually quite expensive. And this has kind of been an ongoing struggle in cloud in general, because a lot of people start in the FAS world, and it's great, and then they hit this point where it's like, oh, actually, it's not great because it's really expensive up when I can saturate a core, and I have to figure out now how to go to IaaS. And so I think part of the goals in providing these richer developer experiences is to give people continuity, so that you can start small in functions as a service, pay only for your requests that you have, but then when you get big enough, you end up running in a Kubernetes cluster, paying infrastructure costs. So I think that's the way that we approach this, is hopefully giving people developer experiences that can span from whatever sort of funding model works best for their particular environment. So.
Awesome, thank you. I do have to say I really like this concept of the whiteboard session. Good. It's very interesting to hear you answer the questions as well as follow everything what's happening on the whiteboard.
That's good. I also sorry, I wanted to add one other thing. Sorry to interrupt.
Yeah.
That I forgot to mention. The other thing that we do have is we do now have spot instance support for AKS, and that's dramatically cheaper. Although obviously it comes with a little bit of a reliability hit because you could get evicted. So go ahead.
That segues quite nicely, Brendan. We've been watching the chat, and I want to squash together two questions. One from the chat from fellow MVP Tom Kirkove, who's involved in CADA, does a lot of work with containers, and he's saying that ACI is great, but it doesn't have auto scaling. AKS has auto scaling, but the size and complexity means it might be a bridge too far for smaller apps. And interestingly, tying into that, yesterday we had Vishwas Lele on the stream, and we said if you could ask Brendan one question, what would it be? And it ties quite nicely into what Tom was saying, because Vishwas wants to know really when you're going to make AKS a bit more PaaS-y. So things like scaling will be automatic. So size might be a bit more automatic. So maybe spanning that gap that Tom's identifying between ACI and its big brother AKS.
Yeah, I mean, this is an ongoing question. I really think that ACI is a low-level primitive, right? And AKS is roughly in the same boat, but more complex, as you say. So we put AKS maybe a little bit higher, but roughly in the same a boat. What I want to actually see us do is, and of course, if we do virtual nodes, this is actually connected to ACI, the virtual nodes. What I actually want to see us do is, and this gets back in some ways to the answer to the earlier question, I want to see us lay in higher level experiences that you can use to achieve this. So I don't necessarily want to make AKS more PaaS-like, but what I do want to do is bridge the gap between things like app services and AKS, so that if I want to interact with AKS at a PaaS layer, I can interact there and I can get the support, right? Because there's a couple different aspects to PaaS. One is the developer experience. And you can basically have the developer experience today, right? I mean, you can take any number of Heroku clones or functions as a service on Kubernetes, or Azure Functions has done a bunch of work to run on Kubernetes. You can take that and do it today. But the thing that you're missing that you would get with an app services or Azure Functions is the person, right, who's on call, who gets woken up if an alarm goes off. That's my picture of an alarm going off. And that's the thing that's missing, right? And so what we need to figure out how to do is how can we deliver that kind of service guarantee on top of AKS with things like auto scaling and all that sort of stuff, so that you can have that PaaS-like experience still sitting on top of containers, so that you can drop down if you need to, or so that you can also at the same time run something in a Helm chart alongside your PaaS-y application. And so I don't necessarily and I don't want, this was the thing we debated a lot actually when we created ACI, was sort of like, how much orchestration should we put here? Right? How much orchestration should be available for ACI? And the reason we did virtual nodes is because I really strongly believed the world doesn't need another orchestration API, even a really simple one. Right? I just don't believe that we should be bifurcating, that we should be creating this sort of bifurcated space. I'd much rather see us say, hey, look, we're not gonna do that. We're not gonna introduce new orchestration APIs. Sorry, my eraser is really laggy. But what we are going to do is try and build higher level experiences. Maybe this is even something like no code. We're going to try and build higher level experiences that sit on top of the Kubernetes APIs that with virtual nodes sit on top of ACI. And so it's a more complicated stack when you look at the picture. Hopefully, the user doesn't necessarily see this picture. They just see the no code experience or the PaaS experience. But but that's the direction we're pushing in, because I think one of the other things that's really important to realize is that more and more our developers aren't just thinking about, this part, which is in Azure. They're thinking about this part also being, if I move it over a little bit, they're also thinking about this part being on the edge. Or potentially even their own data centers. Data center. And in that world, they're going to have some other K8s here. Not AKS, but we still want to be able to deliver those exact same experiences. And we're starting to see this with Arc, right? So this is why Arc is so interesting to me, is we're starting to see, hey, you want SQL Server? Well, I can give you SQL Server via Kubernetes in your own data center, on the edge, in AKS, all with the exact same experience, right? And same thing with Azure Functions. And I think that's the trend in general for how we get to these simplified experiences, is to focus on making those higher level things more portable. So that's sort of the answer that I would give. I think that, I guess I'll taking another stab at this. I think when we think about paths, what has happened traditionally in the past is, if there were machines at the bottom here,
mm-hmm.
The PaaS has been built as this sort of very siloed kind of thing, and all of the PaaSes were built up and down, all the way from the user experience, all the way down to the machine. And I think, what we've seen is that Kubernetes has come along and kind of sliced out some of that. But if we still build these things in these vertical sort of monoliths, even if they're on top of Kubernetes, it's still very hard for them to talk to each other. And so what I'm really trying to push towards is a more componentized experience where, I love what you mentioned, Kata. I love what we did with Kata. That's a terrible, I don't know what happened there. It tried to do a shape. I love the intelligent shape thing that these things do usually, but then every once in a while it just totally messes up. I love what we did with Kata because it's this modular thing that you can use anywhere. And so, I see that something like Dapr is the same thing, right? So it's a little modular piece. And so I want us to see us build up these little modules that sort of fit together to ultimately deliver the developer experience at the top, rather than building these verticalized, complete, beautiful if you're inside them, but very tricky to interoperate kind of systems. Because I think historically that just hasn't worked out very well. In the limit, and then everybody just goes back to the low-level infrastructure, and we don't make progress forward. So that's sort of where I'm at with that. Sorry, I feel like that was kind of a long answer, but
no, it's good, of course. Awesome, thank you so much. Okay, then we go off to the next question. So the following question coming in: Kubernetes has quickly emerged as the de facto container orchestrator across all the major cloud platforms as well as on-prem. Is this a good thing because it offers choice, flexibility, and portability? Or is it a bad thing because the need for a generic platform can stifle the opportunity to differentiate on capability or features?
Well, I think ultimately it's a good thing, right? Because, portability, our customers require portability. Really, the world requires portability because, first of all, many of our customers are going to be in multiple clouds for a variety of reasons. Maybe you're a infrastructure provider like Snowflake, and you're just going to go to all the clouds because your customers tell you to go to all the clouds. Maybe your board has told you have to be in multiple clouds for reasons of financial liability. So many of our customers are multi-cloud, and they don't want to have multiple teams, right? They don't want to have a different team for each cloud and a different developer experience, for each cloud. That's really bad because then if somebody wants to transition from team 1 to team 2, like, you've lost portability. You've lost skill portability. You've lost you've lost people's incentive, honestly, to stay at the company potentially, because if they want to leave their team, they may go someplace else rather than switch teams if it's too hard to switch teams, right? So I think, there's a lot of customer value there. There's also a lot of ecosystem value, because it means that we can build projects. And, when we build a project, it's just a project. It doesn't talk about what cloud it runs on. So if this is something, I've been doing some machine learning stuff lately. So like all of these machine learning tools that are out there, they just target Kubernetes. They don't target, Azure or target, VMware or target whatever, on-prem specific thing. They target Kubernetes, which means that as a user, you can take it and you can take it to whatever cloud you want, right? That means that more people come and use this tool, which means that the ecosystem grows and is better, and it's a very virtuous cycle, And I think that's hugely valuable, not just for, the cloud ultimately, because it's our customers. Our customers' success defines how good we are in the cloud. But also it's good just for the ecosystem of software, because it means that we're all focusing in on building together instead of, everybody building for their own little silo. And we always do a better job. I mean, just like there's more people, so we're going to do a better job if we're building together. I think for the question of differentiation, I think there's still a lot of opportunity for us to differentiate as well, because I think, one of the things that we're doing with Azure is we're saying things like, hey, what's really important to people? Well, I think policy is really important. I think developer experience is really important. And so we're going to focus on some areas like this, like they call this broadly enterprise K8s. And developer experience we talked a lot about. And we're going to focus on this, and we're going to make these things be our differentiators, right? And we can actually do a lot, even in the context of an open API, to differentiate ourselves. And sometimes even the differentiation itself is actually open, right? So we've done a bunch of work with VS Code for Kubernetes and VS Code generally. Obviously, it works anywhere, right? But it still means that we are the experts on that tool. And so when our customers come to us and say, hey, how do I make my developers productive? I know I want this Kubernetes thing, but I have to make it work inside my enterprise environment with weird network, with some network admin who's saying that that there's this whole thing that you have to do. There's a checklist. I'll draw a little checklist. It's like a little checklist that the network people want you to fill out before you can go to production. How do I do this, right? How do I do this? How do I make my developers who've never done a container before, how do I make that developer productive, right? If the developer's like this, I think we can point to these things and even if they're open and even if they target everywhere and say, look, we know this, we built these things, we can help you along that journey. So it becomes sort of almost a cultural and information thing, as opposed to like, oh, this software only works in one place, right? And I think that's how you differentiate in cloud in general, I think, because, we're really not selling software, we're selling services. And so, we're not going to I don't think we're going to do a lot of differentiation based purely on software that's exclusive to us. It's going to be more about the holistic, like what do we empower? What do we enable you to do that you couldn't previously do?
Okay, so I want to move us on a little bit, because it's not just containers that you're responsible for. You called out Dapr a few moments ago, and actually that's kind of cool, because Mark Fussell is going to come and talk to us after yourself about Dapr. One of the things that Dapr is really, really great for is abstracting away some of the things that developers need in cloud applications, like managing their storage and instantiating state and that kind of things. And a lot of those ideas have come from Service Fabric. And given that move for Dapr, which is focused on Kubernetes as well as more cross-plat support, a lot of us who love the technology are wondering, where does this leave Service Fabric? Are you able to comment at all on how that might be developed in future?
Well, I think there's two parts to this. One is that that core infrastructure still is still powers important services from SQL to Intune. So like it's incredibly important infrastructure for the services that we develop inside of Microsoft. And similarly, I think what is interesting is, as you say, a lot of the ideas around developer and developer experience are really valuable, powerful ideas, right? You know, and I think that I think there's a focus on trying to build things that are in this broader ecosystem, as I said. You know, I mean, as I said, I think our customers require that systems that we build be things that they're familiar with and things that they're using on other clouds. And you know, that's Kubernetes is filling that is the standard there, right? And so a lot of our focus is on saying, okay, like how do we think about improving developer productivity, and how do we, you know, take things that we've learned about how you can improve developer productivity and make them more broadly available. I think a great example of this actually in Dapr is that, you know, Dapr runs entirely as a bunch of sidecars. And so it's language agnostic. You know, you want to talk to Dapr through Python? Fantastic. You want to talk through Go? Fantastic. Rust, you know, C++, whatever language you want to use, you know, you can talk to this sidecar. And that means that there isn't a really tight binding between a developer experience and a programming language. I think, you know, we're in a polyglot world for sure, and that's really critical. That, you know, no matter what language a company or a developer chooses, they can have access to the same set of tools. So I think there's a lot of, you know, there's lessons learned on both sides. And, you know, as with all software, what you do is you take the ideas and you iterate forward. And so I think that's what we're, you know, that's what we're doing. You know, I think it's always really important to listen and to focus on what your customers need, and where they have gaps and where you think you can help them. And that's what we do every day, and we continue to do. So.
Okay, good. Thank you. So let me check what else is coming in. Okay. So at this point, it feels overwhelming to grasp and keep up with the plethora of third-party tools and frameworks in the CNCF landspace. However, some of these in relation to Kubernetes have a huge impact in working with containers. Which are your favorite tools and frameworks for the CNCF, effectively the ones you believe should never from a team's toolset, which one to be serious about Kubernetes containers, AKS, etc.?
Sure. Well, I mean, I think this is an important question because I think there is a little bit of like, you know, it sort of reminds me, actually, I sort of joked with people a while ago, you know, I think all the infrastructure people got jealous of all the JavaScript front-end people. Because I remember when, you know, JavaScript front-ends are still kind of the same way. Like, there was a new framework every 2 weeks. Like, every 2 weeks, the UX people who were next to me were like, we're done with, and it was like, insert whatever. Like, I'll show that I'm old. It was like, we're done with jQuery. We're moving on to backplane. We're done with backplane. We're moving on to vue.js, or, you know, whatever. I'm not a UX guy, so I probably totally messed up the different, you know, frameworks for JavaScript. And so I started to joke that like the infrastructure people got jealous of everybody being hipster about their JavaScript frameworks, and so they created, you know, the CNCF to be an antidote to that. But I do think that sometimes, you know, people kind of adopt things just because they want to like talk about the thing that was on Hacker News or whatever. And so I would really focus people on, you know, I always, whenever I'm talking to customers, I start with, what is your pain, right? Like, what is the thing that bugs you? You know, maybe it's that your monitoring system, you're not happy with your monitoring system. You know, you can go use something like Prometheus. I think Prometheus is emerging as the sort of de facto standard, at least in terms of scrape format, in terms of presenting metrics. Now you could say, hey, for monitoring, I really want to use monitoring as a service, and I'm going to use Azure Monitor, which is great. I mean, I think actually you should use monitoring as a service if you can. But even there, that thing knows how to scrape Prometheus metrics, right? So, and we know people who actually use Prometheus as a local aggregator before for collecting metrics inside the cluster before shipping them to Azure Monitor, so that they ship fewer metrics to Azure Monitor. So I think Prometheus is a really great tool. Grafana is not actually in the CNCF, but it's a great tool, which I think is another demonstration of the fact that you don't always have to be part of these foundations. HashiCorp has a bunch of great tools that aren't in the foundations. So I would really focus on what are the things you're trying to solve. Maybe it's distributed tracing, so you go look at Jaeger or other things. Maybe it's stuff in the event space, and you're going to go use cloud events and the cloud event spec. I wouldn't view the landscape as a checklist. And certainly there's stuff like Sandbox. So I know this from being on the CNCF technical oversight committee. There's stuff like CNCF Sandbox where like those projects, all they need to get in there is approval from 2 members of the committee. It's a super lightweight process, right? We really focus on making Sandbox be super, super lightweight. And so as a result, it's not necessarily a huge endorsement that a project is in the CNCF Sandbox. I would look more at things that are in incubation or going to graduation as a sign that the community has really rallied behind them. And so things like Helm, that are actually graduating into the full-on, Kubernetes, or sorry, not Kubernetes, the full-on CNCF projects like Kubernetes. I think Helm is used by like 80% of people who work with Kubernetes. So if Helm is something I would definitely recommend if you haven't already played around with it. So I think that's the way I'd approach it. Like, I do think there's a role that, I've talked about this before, if there's a role for us to play too, as kind of, we don't necessarily give people an opinionated stack right now, but I've sort of said, maybe we should just kind of like say, hey, these are the 6 things that we would use if we were you. And we do that in sort of one-on-one conversations, but we don't necessarily publish stuff like that. We kind of don't want to be kingmakers. But there's a real hunger out there, I think, for people to understand, what is the things that are useful, and what are the things that are just sort of hype.
So, Brendan, one of the things I find a lot with the move to containerization is organizations use it as a very valid way of dealing with sticky bits of their old application, their legacy code, the things that are hard to move to more native cloud services. But whilst that's great as an accelerator for getting into the cloud, it's also potentially creating another anchor, right? Because they've dropped this legacy code into a container and they think that they can forget about it. They don't need to look at it. They don't need to rework it because it's in and it's functioning, right? What advice would you give to organizations to really make containerization a driver and enabler for improvement rather than just being a new hosting environment instead of a virtual machine?
Yeah, I think there is some value in, so let's say, you had a bunch of monoliths, or not monoliths, but a bunch of little apps over here. And you said, okay, actually, we're going to standardize everything in Kubernetes. But you end up with the same sort of like mix of random apps in Kubernetes. I think it's still a win to a degree, right? Because the API layer, you've given yourself a better API layer. And that's useful there. But I agree with you that if you just declared victory there, well, it kind of depends. Maybe you drove your utilization. Maybe over here you were at like 10% CPU utilization, and here in Kubernetes land you're at 50% utilization. That might be the win, and that's okay. But you shouldn't necessarily think that you've changed your culture. I guess I would go back to what I said earlier about getting customers to understand where their pain is. I think that the problem that you're talking about is that actually a lot of the pain with that big monolithic app that somebody had, a lot of the pain comes from the fact that like you have team 1 and they contribute some code to that monolith, and you have team 2 and they contribute some code to that monolith, and you have team 3 and they contribute some code to that monolith. And now when it comes time to deploy, Well, you have to coordinate. You have to get this sort of magical coordination between all of the teams in order to push code, in order for you to go from V1 to V2. And that coordination is really hard. And also, sometimes there's a bug, right? So sometimes this team will have a bug. I do a really terrible job of drawing a bug. You wouldn't think that I have an art degree. I actually have a degree in art, but I was never a drawer. I never drew. Drawing was not my thing. So this team has a bug, and it ends up rolling back software. So you go back from V2 to V1, and it has an effect on these other two teams, right? And that's really painful for a lot of people. It means that the agility of your company is a lot slower. Your teams are frustrated. There's lots of like ship room meetings. Nobody can kind of move at their own pace. And so this is a real pain for a lot of people. And if all you do is take that monolith with, all those different teams, and you push it into Kubernetes, well, you haven't really changed anything, right? You still have that same problem with multiple teams going into the same binary. And so that's when I would say, like, oh, okay, now actually you need to really think about breaking this thing up, because you haven't really achieved your goals, and you need to break this thing up so that, you extract out what this team works on. And maybe that's enough, right? Maybe team one, the blue team stays and they have their monolith. And they get to keep the rest of the monolith. Or maybe even there's still a couple other teams that are still in that monolith. But by moving from 3 teams to 2 teams, you've reduced it a little bit. And maybe eventually this team can move out too. Because I think the other failure that I see is sort of this, like, the failure of the parallel tracks, where a company says, okay, we're going to move to Kubernetes, but the way we're going to move to Kubernetes is we're going to start with our monolith over here, and it's V1, and then we're going to have Kubernetes over here, and we're going to build a beautiful new system with it perfectly architected in all the right ways, and all the little microservices. But in the meantime, we're going to keep working on this. So we got V2 of the monolith over here. And by the time this thing's ready, this is V1 prime, say. By the time this whole thing is ready, it's this and not this. So it's not V2. And then people say, oh, well, no, you can't ship it because we need V2. And now you need to go spend some time catching up. So catch everybody up to V2. But by the time you finish and everybody's caught up to V2 in your new beautiful monolith, or in your new beautiful Kubernetes system, they've built V3 of the monolith. And so, like, the sort of like, hey, we're going to build a firewall between the old thing and the new thing almost never works. You have to sort of, change the engines while the plane is still flying. And so that kind of incremental, I wouldn't say that shifting the monolith into Kubernetes is a bad thing, right? Probably the right first step is to shift the monolith into Kubernetes, but then breaking it apart, remembering that you still have to break it apart, and remembering why you wanted to break it apart. That's sort of like the second important piece. And I think more people are beginning to realize that pattern now than did previously.
Okay. Good. Thank you. Then let's check what else we have. Okay, so here's the next question, Brendan. Currently, when working on AKS, we will have development tools and languages for both platforms. We manage our clusters using ARM templates, Azure CLI, etc. on one hand. On the other hand, we are using YAML, Helm, charts, and this is actually an interesting one. Is it kubectl or kubectl? I'll take Brendan on the right way to say it.
Kubectl. That's what I say. I say kubectl. But I know plenty of people who say kubectl. But I've always said kubectl.
Then let's say kubectl. Good. So for managing what is running inside our cluster, are there any plans to make the management and provisioning of what is running inside our pipeline feel more native to the rest of Azure?
Yes. So I think the answer to that is yes. And I think we actually have active plans in both directions. So, you can say, hey, I'm in ARM land, and I want you to take that Kubernetes thing, and I want you to project it into ARM so that I can have sort of /pods, in my ARM template. But other people say the opposite, which is they say, hey, I'm over here in YAML land, and I like my YAML, and I'm in, using kube control and things like that. I want you to take ARM and project it over here so that I can have, /VMs in my Kubernetes cluster. And these are both actually really valuable and important perspectives. And as we do Arc, and you can sort of see maybe where the name came from, but as we do Arc, we realize that we need to supply both. And so, we are simultaneously working on an ARM to Kubernetes bridge. So a bridge that will take Kubernetes and place it into ARM. We're also working on this thing called the service operator, which makes it possible to create Azure objects. It sort of takes Azure into Kubernetes. It makes it possible to create Azure objects using a Kubernetes native kube control YAML workflow. So it kind of just depends on, where people's perspective. Do they want to be Kubernetes tooling centric, or do they want to be ARM centric? And we know that we really need to provide both experiences. So those are things that are being actively worked on right now. So as well as actually language improvements to ARM templates to make them a little bit less JSON-y. Because I think one of the other things that we talk to people about is how one of the reasons people prefer the work that they do in the Kubernetes config world is because the YAML is just a little bit cleaner and easier to read than JSON.
Okay. I'd quite like to throw a bit of a left field one at you now, Brendan, if that's okay.
Always.
Magnus Martinsson, who he's one of the organizers of Global Azure Virtual, he said, if we gave you a wish, okay, you've got a pot of seed funding that you can give to anything at all inside the Azure family to develop to make it great. Where would you go and spend that seed funding?
Like an existing thing to make great, or like a new thing?
Either or, it's your wish, right?
Man, there's a. Well, I mean, I think that there's a bunch of stuff I would love to just accelerate. Like, actually, the best thing that I wish we could do is just speed up time, right? Because like a bunch of the stuff we're working on, I really just want to see it. I know where it's going to go, or at least I really hope where it's going to go, like Arc. But it takes time to develop. It takes time to get there. And so I want to fast forward. Like, I want to fast forward 18 months. But if I could sort of fund a brand new effort, and I guess I'm also sort of lucky because I do actually just get to fund brand new efforts sometimes anyway. But I think that the work we're doing in the developer space that I talked about earlier is the most important, right? I think that it's still, I think about the fact that, and I think a lot of people think about the fact, but I sort of flash back to, let's say like 1998, and you have a database, and you have, a console, or not a console, you have a graphical single machine app talking to that database. It's sort of a forms over data kind of app. And you have something like VS Code or VS that you built this app from with a designer and all this stuff. This whole thing, this is about the apex of, that's not great. But anyway, this is about the apex of development, in my opinion, right? In terms of ease of developers, right? I think back to friends that I had fresh out of college, history degree, having software engineering jobs or even companies based on this whole thing, right? The tools were that easy, the development was that easy, right? And fast forward to 2020, and it's a mess, you know? I mean, it's like I mentioned all those graphical frameworks. It's just like nothing but question marks, right? And a bunch of tools that sort of work, but nothing that provides you with as sort of integrated an experience. The whole IDE part here, we've lost a lot of the I, right? The integration part. And that's a shame. I mean, there's a lot of really good reasons for this. Like this architecture doesn't work anymore, right? The old architecture, it doesn't work with smartphones. It doesn't work with tablets. That's my smartphone. It doesn't work with tablets. It doesn't work with shared state between those devices or between people. You know, so there's nothing like Office 365 where I can share my docs between people. Like expectations have changed, right? So this architecture doesn't work anymore. But in changing the architecture to adapt to the business requirements of people and devices, we've actually put a ton of pain on the developer. And so, like, if I could, you know, wave a wand, I think that's the thing that I would focus as. I mean, and we are trying, right? We are focusing our energy on that. But that's the thing that I think is the most, like, that I feel the most urgency about. Because at some level, like, we're doing the world a disservice, right? Like, we should be making this easier. Like, that should be our number one job, is making that thing easier. And I think it's just really, really hard. I mean, some of the things I tell people about, I'm like, well, like, look, you know, this 1998 experience, if you considered it sort of the apex, it took 20 years at least to get there, right? I mean, it took from, you know, the mid 70s, maybe even earlier, through to 1998 of people making better and better development tools to get there. It's going to take a while for us to get here, right? And I don't know when the clock starts. The clock maybe starts in like 2008, 2010. So we got another 10 years. We got at least another 10 years of like trying to make the development tools better before we get to a place that I think is going to be reasonable. But that's probably the place that I feel the most urgency about.
So actually tying what you were just saying there about improving the dev experience to something that you mentioned a few minutes ago. JSON would not be my first choice of language for infrastructure as code, although I can totally see why the ARM guys picked it. And I realize it's my personal preference, but I hate YAML with a passion. Are there any initiatives maybe being incubated at the moment? Are you thinking about maybe changing how some of that infrastructure as code is built and the way that we have to write it to make it more developer friendly, maybe human readable, maybe easier to check, that kind of thing?
Yeah, no, we're absolutely thinking about this a bunch. I have this experiment out on GitHub that I played around with. That's sort of, it's kind of React-like that integrates Python and YAML together into a sort of a more, I would think more sort of single readable thing. Because I think one of the challenges you see with all this stuff, one is like just the syntax, right? Like the curly braces and commas of JSON, whatever. But the other is the fact that we're actually combining two things, right? You're combining data and program. Like, because every significant ARM template or every significant config file has some aspect of like loops or conditionals or whatever. And so you're combining these two things together, and it's really hard to do that in an elegant way, right? Because if you go fully programmatic, then your data is really annoying because you're constantly like declaring variables to hold data that just feels verbose. But if you go fully data, then you're doing things like you do in the ARM template language, where you say like, loop, which is a really bad way to, specify a loop. And so it's absolutely thinking about how we make this better. We have some prototypes. Other people obviously also do too. There's companies like Pulumi who are thinking about this. The spectrum sort of goes from pure data on one side, which is sort of, which is basically ARM templates of today, like pure DSL, or through to Pulumi, which is like, it's all just programming languages. I don't think either of these approaches is going to work really great. I think that we should sort of try and land somewhere in between. Or we should just admit that there's just going to be a bunch of solutions, right? And I think actually a piece of both is actually where we're going to land, where we try and develop a language that's a little bit more programmy, but is also sort of data oriented, but also admit that there's going to be Terraform. There's going to be some things like Pulumi. There's going to be people who want to just do YAML. And how do we, just as with programming languages, I'm not sure we'd ever say, hey, there's going to be one programming language to rule them all. I think we have to admit that there are going to be different config languages that suit different tools and different people, or even just people's style, people's just personal style. And how do we live how do we live in a world like that? Is how I think about it. Although clearly there's a room for improvement, right? Like clearly we should do something because, it's painful today. And I think one of the other reasons that things like JSON and YAML are challenging is that they weren't necessarily built with tooling in mind, right? It was a language choice that was made by people who weren't thinking about like, how do I build a really great editor experience around this? And so I think taking a step back and actually looking at how people use these things today and figuring out what's important to them and saying, okay, well, actually, we really need to deliver a great editor experience. And that's a requirement for the language. That's not something we try and bolt on the side. That's a requirement for whatever language we build. I think stuff like that will also go a long way to making it more tractable. Because, as we've seen with some of these sort of uber verbose languages like, Java or even C# like they're languages that were built for tab complete, right? Like they're much less fun to use if you don't have an integrated development environment that's intelligent about taking away, the annoying parts of the language.
Okay. Thanks, Brendan. So we have a couple minutes left. And what we would actually like to know is at the beginning of the call, you mentioned you're sitting in your basement. Rick is sitting at home. I'm sitting at home. We're all kind of stuck in this current situation. So how has it been for you in the past weeks? Like, are you always working from home in the basement now, or how has your life changed?
Sure. Drop my screen share. So I've been lucky in a couple different ways. I was lucky in that Seattle decided to have the driest first like 4 weeks of 3 weeks of April that Seattle has had. I think we're not going to be the driest month on record, but pretty close. So it was beautiful. So I was actually mostly working from my yard.
That's nice.
Which is really nice, right? And I actually got a sunburn, so which I was surprised by. I was like, wait a minute. So
in
that's
April.
In April, exactly. In Seattle, right? I was like, in April in Seattle. It's not. I think my body just wanted to be in Hawaii. So I that was nice. It helped a lot. I work from home a little bit anyway, and I'm also lucky because my teams have been pretty remote friendly historically, and so my teams adjusted to this pretty well. I'm lucky because my family's in a situation where having the kids home they've been great, and my wife has really helped a lot. She's great at making sure that they stay on track and things like that. So I feel really. I guess I would not complain at all about the things that we've gone through, because I think that I've seen a lot of people who are in way more challenging situations.
Yeah.
And so yeah, I mean, I think we've made the adjustments. I think one of the most important things one of my teammates said was, pretty early on, we started treating this like it was going to be the new normal, right? It wasn't sort of like, oh, hey, let's, we're going to just sort of somehow, gut check our way through this for the next 3 weeks. It was like, no, we're going to be in this mode for at least a couple months.
For a long time.
For a long time, right? So like get the ergonomics right. Get that monitor in the right place. Get a nice chair if you need a nice chair. Get a nice chair.
Yeah. Get a tan in the yard.
Yeah. Get a tan in the yard. Yeah.
Yeah. So you also said earlier you used to be a college professor. Are you homeschooling your children now at the moment?
Well, I mean, I think we're all sort of becoming a little bit more teachers, but my kids are also in remote classes, Zoom based, and Teams. One of them uses Zoom. One of the schools uses Zoom. The other uses Teams. So there's a mix. But obviously it's different, In some ways it's easier because I don't have to be like, hey, we're going out the door. Is everybody? I'm like, did you get dressed and hop on your iPad?
We're all at home.
I'm really sorry to interrupt, Brenda, but we need to break. But I've been asked by the producers, quickfire round, tabs or spaces.
Whatever my IDE does. I like the tab key, right? But my IDE turns tabs into spaces.
Hedged like a true diplomat. Okay,
that's right.
We're going to take a 5-minute break now. We'll be back shortly with Mark Fussell talking about Dapr. Thanks very much.
Thanks so much for having
Brendan.
me. Enjoy. Take care. Bye. Stay safe.
See you. Take care.
Exactly at 10, yes?
Okay, so while we were on break, we carefully discussed what we were going to do next. Denise said, I'll introduce and then throw to you. And then sat there. So, right, okay.
Let's go.
Nature abhors a vacuum. Welcome back to Global Azure Virtual with myself, Rick Hepworth, and my esteemed co-host, Isidora Katanic. And we are joined for the next hour or so by a chap who is always a source of the most interesting sessions at conferences like MVP Summit. He's previously talked about things like Service Fabric and running the sort of underpinnings of Azure. Today, he's here to talk about Dapr. Mark Fussell, you're Principal Program Manager of the Azure Incubations team. Welcome very much to our live stream. What is the Azure Incubation team?
Oh, well, first, it's fantastic to be here, Rick. It's super exciting. I think you're putting on a great show. I've been following along with some of the sessions that you've been doing. The Azure Incubations team is underneath the Azure Office of the CTO. The CTO of Azure being Mark Razonovich. He has a number of teams underneath him. And the idea of the incubations team is that we take on slightly more risky projects that we think will be industry changing. And examples like that are the distributed application runtime and another one that we have been doing, which is called an open application model. So we have a number of these coming along, and you'll see more of these coming out of the team in the future. And we like to take on sort of slightly things that maybe some of the product groups wouldn't necessarily have the time to take on.
That sounds genuinely interesting.
It is.
Today, you're talking to us about Dapr. From sort of our perspective as MVPs, maybe the outside world, it feels like that's drawing on a lot of the ideas of Service Fabric. Is that reasonable to say?
Yes, it is reasonable to say. I mean, what we realized over the years as people built applications, Service Fabric was one of those that was a very well integrated stack. It had everything from clustering technology, distributed systems, had failover management built into it, discovery services, all the way up to these top-level programming models. But as people started to use other distributed systems, particularly like Kubernetes and AKS, things like this, they asked, well, how can you bring some of the benefits of those top-level programming models and the ease of building distributed apps to other platforms? And so Dapr was spawned from that in order for you to take advantage of embracing every developer and every framework so we can give love to the world.
Okay, that sounds really interesting. Well, we've got about just over 45 minutes for you to talk about It's a Polyglot Developer World, and then we've got maybe 5 minutes or so at the end. We're keeping an eye on our stream, and if it's okay with you, if we see questions in the stream, then Izzy and I will throw them at you as you finish.
That's good. That's perfect. I've got a nice session here, so I'll see how it goes with timing, and hopefully we can pack it all in.
Brilliant. In which case, over to you, Mark Fussell.
Fantastic. Okay, let me do my screen sharing here. Open this up, share my screen. Okay. Hopefully you can see this slide. Let me just minimize this here. Okay, welcome to the session. It's a polyglot world. And I'm going to be talking about distributed application runtime. And really what this is all about is that we want to bring the love and ease of distributed systems development to all types of developers, whether you're coming from a favorite language or a favorite framework. And what we see today is that developers struggle to build these apps. We see people who have take existing code that they've built, like they built it some on J2E framework, and they're trying to take that to the cloud, or they may have some existing on-premise application that they're trying to take to the cloud. And the last thing they can do is start to throw a lot of that code away. They want to incrementally move that to take it to the cloud. Even when you're in the cloud and you're building it with different frameworks, we see that some frameworks have particular limitations. wouldn't it be lovely if I could do publish and subscribe between my two Azure Functions apps, which I can't today, and you have to sort of depend upon that particular framework to build those features in there? Or wouldn't it be lovely inside my Node application that I could have long-running, stateful, fully persistent services without me having to do the hard work of hooking up a back-end store? And then finally, we see a lot of this where people kind of target particular runtimes and platforms. It's only bound to the cloud, it's only bound to the edge, it only runs on Kubernetes, it only runs on Swarm, it only runs on Service Fabric. So we want to break down all these barriers and effectively enable people to build distributed apps wherever they come from. And so that's the goals of Dapr, or the distributed application runtime. This is the website we have, and it talks about Dapr as being an event-driven portable runtime for building applications on cloud and edge. And we launched this back in October. We had a number of press articles. We wrote a great blog post about this. You can go and refer to some of those. And since then, the community has been growing pretty rapidly, and we've been having a lot of community engagement. In fact, when we first launched, we only had a few components inside there and a few of the building blocks I'm about to talk about. And now we have over 100, nearly 130 external contributors in the few 6 months that we've been there. And I'm not going to kind of be able to cover everything inside Dapr, but if you want to go off and learn a little bit more about it yourself, Mr. Mark Rizonovich did a great talk back at Ignite that I'm going to check out. I did a bit of a live session earlier this year. And we've had MVPs do some great sessions on this. And in fact, I noticed even in Azure, you've got some other sessions on Dapr, which is fabulous. And of course, dive into the repo, go to github.com/Dapr, go to the Getting Started guide. And I'm going to give you a little intro to what this is like today to give you a taster of it all, but you can go through many samples there of getting going. So the goals were that we wanted to build and bring best practices building blocks, rather than you going off to the Azure Developers Architecture Center and reading all about building distributed apps. It's like, how do you just codify that up and give me something that I can get productive with? And, I don't want to come it from the language and the framework that I'm using. I'm an ASP.NET developer. I'm a Python developer. I'm a Rust developer. I don't want to have to go off and relearn your language to get some of these best practices. The community drives the project. Everything's built inside the open. We adopt standards, things like cloud events, open telemetry for diagnostics. And we build open and consistent APIs so that this is available from all platforms, being deployed across cloud and edge. And importantly, and I'll show you this, Dapr is a very pluggable, extensible platform. So you can come along and plug in what we call components to take advantage of all the capabilities. Let's dive in a bit more. At its heart, Dapr has this concept of a building block. And a building block is an API that gives you some capabilities. For example, you can call from one service to another service through service invocation. And that will do the discovery of where the service is. It'll find out where it is, and it'll do all hard problems like retries and circuit breaking, and as well as discovery of the service. So these building blocks are exposed over HTTP or gRPC APIs, and on top of that, you can call them in from the language of your choice. And how do you do that? Well, at its simplest level, it's like a REST API. You can call onto a local host endpoint. In this particular case, you can call on the state building block here to call the inventory server, the inventory store that I want to call. I want to retrieve a particular piece of state under the key order key. So the state management building block gives you straightforward key value access that you can use, for example, in your shopping cart or your gaming session or the workflow state that you're saving. Or I can invoke over another simple API, another method. I can invoke the new order method of my app, somewhere wherever my app is running. And the way Dapr achieves this is has a local sidecar library. This gets dynamically loaded as part of your app, and an instance gets created for each one of your applications that spins up. So this is what it looks like. Effectively, you spin up your code, your service A and your service B, all part of your larger application. And each instance of your service spins up a little Dapr sidecar. These are very lightweight. They're less than 40 megabytes in size. We're fanatical on perf. You'll see later this month, we're going to be publishing perf and scale numbers. And then because of that, you get all these benefits that Dapr provides you. For example, through these Dapr APIs, you can save state into a variety of different state stores. When we first launched, we only had Cosmos DB and Redis, and the community added DynamoDB, Cassandra, Firebase, Mongo, and a number of other ones. You can take advantage of publishing and subscribing messages between your services through a publish and subscribe mechanism. That can include NAT Server, RabbitMQ, Service Bus, Event Grid, Redis, and a whole bunch of others you can plug into. Or you can take events from external systems. You can trigger your code inside here from a message that comes in via Twilio or a Kafka queue. And then best of all this communication between your services is entirely secured over MTLS, so you have secure communication. And then we track all these calls that happen through both the pub subsystem and the calls between your services and give you deep observability. And I'll show you what that looks like. So I can see call graphs, I can see metrics, I can see logs. So Dapr provides you sort of all these benefits, releasing you to be able to write your code. The good thing about this platform that Dapr has will run on any different types of infrastructure. I'll show you lots of things that you can run just on your local machine. And we've implemented deeply with Kubernetes, so you can run that, and other platforms such as running it on Service Fabric and Docker Swarm and Cloud Foundry. All of those can come in time. And because we kind of have the ability to deploy to just simple VMs or to sort of Kubernetes environments, you can run across other clouds pretty easily as well. So let's kind of dive into what these building blocks are, and I'll show you some demos. These are the 7 that we're sort of starting off with. And these cover from calling between services for service indication, saving state for state management, doing pub sub between your services, triggering from external events, actor-like frameworks for encapsulating code and state, and then observability for seeing your diagnostics. And finally, and I think one of the most exciting that got added by the community was secrets management. We came across many people who just wanted to be able to retrieve a secret very easily. And now you can do that over a simple API. Let me show you a couple of PowerPoint slide samples, and then we'll go and see what one looks like. So service invocation. Here I am, front-end app. I want to call my back-end cart application to save some, to get the data from my cart. And I can just say, call invoke the checkout method, and Dapr will route the call correctly to wherever the cart instance is running. And you can do that, and then response comes back as well. So this is a kind of a two-way call that I may be able to do. Or equally, I want to be able to save some data. My app can post a local endpoint here over to state with the store name I want. Here's the key value data I want. And then this gets stored as key value data in the database of my choice, or the store of my choice. You can make this, I won't have a chance to dive into this quite too much, but you can make this transactional data stores. So you can do multiple state transactions if you want, and you can do various different types of concurrency models on top of it all. And then by calling a get method on here for the actual name of the key here, for example, the key here is planet key, I can retrieve back the data that I stored inside here. So let's go and see a little demo of this in action, because that helps solidify it all. Here's one of our applications that we have. That's if you go off to our repo. If you go to Dapr, github.dapr and samples, you'll find that there's a hello world sample inside here that shows you a simple example of how to use these APIs in order to get hold of state and do calls. So this is a node application I have here. It's a very simple node app. And it just has a couple of endpoints here, order and new order. And you'll see here that the order allows me to receive an order, and it saves that order, and it retrieves the order that I get sent from me. So here I have this state URL here. I can just call on to this particular store name here with state, and I can get back the particular order. And equally, the new order method here will create a key value store of my choice, and it will save it to the state store here, which is this way I've described my state store here. So how do I plug in my state store here? You define these components. And in this particular case, state store name here is a Redis component here called state store. So this is just saving it in a local Redis state store. And I can plug this in and change this. So if you want to get going with Dapr, Dapr has a very simple CLI. You can do Dapr init like this, and Dapr init gets sets up your local development environment for you to be able to get going. And that includes, for example, deploying Dapr onto your machine and configuring things like a local state store here, which is a local Redis state store that I can just use for testing out, saving some state data to. And then this Dapr CLI is fairly comprehensive. This Dapr CLI that you can use takes advantage of being able to run your application or post or get instances of it where it's running, or take advantage of various different types of commands that you can do. So instead of just running this application with, as I would normally with a Python or a Node command, I can actually trigger this application and take advantage of the Dapr run command. So what the Dapr run command does is it says launch my Python application with a particular ID and launch this particular Python app. Now, I haven't showed you the Python app just yet here. This is a Node app. I have this Python app here as well. And what the Python app is doing is it's calling onto that method new order endpoint I showed you in the Node application, calling the invoke method. It's just creating a key value pair here state and calling onto that and doing a service invocation. So here's this Dapr URL. It's calling onto this and saying, here's my order that I'm sending you. So in this world here, I have my Python application I'm going to spin up, and I'm going to spin up my Node application, and you'll see them sending messages between each other. So let's spin up the Node application here. As I spin up this Node application here, I will also open up another terminal. Here we open up another terminal. Let me just grab a little command here at the moment so I can save me typing, and I'll spin up my Python application. And there it is, my Python application is spun up, and it's starting to generate and send orders into my Node application. So if I spin back here, you'll see that my Node application now is receiving these requests here. It's calling onto the invoke method. These are running in my local machine, but this can be in any environment. And as it calls onto this new order method, it takes the data that I get out of the request and puts it into my Redis store. So you can see here, I've got my Redis Explorer. If I look down here, you'll see that I've got order 7, order 8, as I go and persist this data locally. So this is a super simple way just to show I have now created a long-running stateful Node application using Dapr to store key value pairs of my data. And you can store any amount of data in there that is useful for your application. So what I'm going to do is I'm just going to stop this at the moment, because I've decided, well, I didn't really want to store this into Redis. I wish I'd actually stored it into Cosmos DB. So rather than having to rewrite my code now to pull in Cosmos DB libraries, I can simply say, well, I'm not going to use the Redis component anymore. I'm going to switch out here, and I'm actually going to just rename state store that I had before to be a Cosmos DB state store now, with all the metadata that I need to connect to it. And by the way, all of this can be hidden in a key value, Azure Key Vault, to pull down the secrets information without it being inlined inside here. So now I kind of say, well, I still have this Python application running, but I'm going to actually now restart my Node application. And this time, when it loads up, it's going to hook up instead to a Cosmos DB store. And now it's starting to receive orders, but they're no longer going to this. They're no longer going here to my Redis store. Instead, I'll switch out here and I'll go and look at my portal here. I'll open up my Cosmos DB store here that I'm posting these things to. If I go and look at the Data Explorer and load up the Data Explorer, I have this database here called orders. And if I look at the items inside here, you'll see now that I'm starting to see my orders coming inside here. If I refresh this, there's order 34, order 35. So now by simply switching out the component that gets used, the orders now are being, instead of saved to a Redis local store, they're being saved to a Cosmos DB store without doing any code changes myself. And this reflects the power effectively of what Dapr provides. You as a developer now can take advantage of these capabilities without having to understand and switch out and understand all the different types of stores or pub sub mechanisms that you want to save this to. And this component model is one of the key things that allows Dapr to become very flexible and integrated into any one of your applications, as well as being able to take advantage of the sort of very simple way of crafting up a URL and being able to use that to save data. So that was a good little demo there. I'll pause at this point. Are there any questions that we should take?
So we haven't had any in the channel, although there's quite a nice little back chat going between myself and Alex, Mark. So you mentioned some pretty interesting stuff in there about sort of service discovery, right? So you've got your different components that can talk to each other in a relatively straightforward way. Is that service discovery entirely within the application, or is there capability or even a desire on the part of the team to expand that service discoverability to, if you like, between applications? So I might have a completely different app, maybe not even written within that Dapr framework, that could call and discover services that are part of my other Dapr apps using the same mechanisms.
Yes, yeah. So the answer to that is that the service discovery mechanism actually takes advantage of the platform. So here we're using it for local service discovery, but when it gets deployed into other environments like Kubernetes, it takes advantage of the DNS resolution inside there. And inside there, I may have app in one namespace and an app in a different namespace, and I can call between any one of those applications that allows me to do that service discovery. You are actually also allowed to isolate them by using those namespaces and prevent that. So you can both use it to your advantage of taking advantage of the platform, such as Kubernetes, to kind of hide your application so they can't do discovery. But at the same time, yes, you could discover any application that's running inside there through the discovery mechanism. So yes, that's entirely possible.
Okay, that sounds really interesting. Mark, we'll keep monitoring what's going on and throw more questions at you later. Perfect.
So now you've sort of got the idea, you can go down and go crazy on all this. So publish and subscribe. It's a very, very common thing to be able to say, I want to build an event-driven system where I want to be able to publish messages that other people should subscribe to, such as, this particular price change inside my application, or, this particular event happened in this workflow, go off and do some processing inside it all. So Dapr has a built-in pub/sub mechanism where you can take advantage of a number of different pub/sub servers, like Redis or NATS or Service Bus or GCP pub/sub here. And then I can have, in this case, an email and shipping service that have subscribed to the topic order. And when they do, they get sent the data packet, broadcast to all of those who subscribed to the pub/sub mechanism. So this is very powerful. It allows you to take advantage of a number of different pub/sub, different types of servers, or and build pub/sub mechanisms so you can do event-driven applications. Likewise, a very common thing as well is that you have triggers from external systems, such as a Kafka queue or event hub sending you messages. And Dapr can sit there and, using the component model, listen on particular external bindings, external systems, and then trigger your code. In this case, I can have an endpoint called trigger, which I configure with Dapr, and Dapr says, what's the thing that you want to trigger when events come from these inputs? So I can trigger my particular piece of code. And you can do the converse as well. Your application can decide that it wants to trigger and send messages out to external systems. So if I wanted to send something to my connection with some data, I can decide whether that connection is a DynamoDB database or an event hub or a Twilio message that I want to send on SMS. And the configuration of the components inside here allow you to change how the message gets sent out. So this event-driven mechanism allows you to have your code triggered, whether you can have messages coming externally or internally or between the actual applications themselves. And while all of this happens, Dapr is sort of monitoring and taking care of your application through observability, metrics, and logs. We take advantage of open census right now as the format, and you can push all that data into a variety of different observability stores, such as Zipkin and Azure Insights, App Insights, or Jaeger. And this is also, I think, is a key piece of this, because a lot of the time developers are having to figure out, how do they do diagnostics inside my application? Dapr takes care of that all for you. And you will soon be moving, in fact, in the next release and afterwards, to Open Telemetry, which is now the standard format that has been represented inside CNCF for the data on the wire that can be pushed into these observability stores. So let me show you a little example of what the diagnostics and tracing looks like. What I'm going to do here is I'm going to pull up the full Dapr samples repo. And at the same time, I'm going to show you what it's like to deploy Dapr into your application into other environments that Dapr uses. So I have my same application I had here before. This is the node application, which is sort of saving my state. But this time, I actually took this application and rather than running it locally, I deployed it into a Kubernetes cluster. And all you have to do in that world of things is that here's my Kubernetes deployment specification for that application. I built that application into a containerized image. And as part of the deployment, in the same way that I showed you the CLR, I indicate here that this particular application, when it gets deployed, wants Dapr as a sidecar enabled on it. Here's a particular name of the app I want to give it, and here's a port that I want to open. So this is sort of like the CLR equivalent in a deployment to the Kubernetes world, launching this particular image that I built here. I can do the same with my Python application here as well. And in this particular case, what I've actually also gone and done is that we have this other application here, which is a calculator application, which is a fun little distributed application where each one of the operations of the calculator is built by its own individual service. So the adder service is written in Go, the divide service is written in Node, and the multiplier is in Python, and the subtract is inside .NET. So those have also been deployed. So if I go and look at my cluster here, you'll see now that actually this is my Kubernetes cluster. You'll see that here's my Python and my Node application I've just got deployed and running inside here. And here's some of the other pods that have been deployed for this application. I'll talk about it a little bit more later, but these are the integration of the services that we have for Dapr in order to make sure that Dapr understands this Kubernetes environment. To get this going on your Kubernetes environment, you simply do Dapr init-k, and that installs Dapr onto your Kubernetes environment. It gets you up and going. And now I can actually sort of take advantage of seeing these applications run. So in this particular case, this calculator application is running, and you'll see it's here. This is this calculator application. So I can do a bunch of operations inside here on this calculator application, and each one of these is pushing and calling onto one of those from the front end React application onto those back end services inside here. So in order to visualize this all, I want to take advantage of seeing some diagnostics. So what I can do is I can turn on a diagnostics tracing tool. I think I've still got this thing running here. I launched Zipkin here earlier inside my cluster. And now both that Python application that we saw earlier, calling and pushing the orders, plus this calculator application, I can visualize all the data that's happening inside here. I can see all the call graphs, and I can see all the trace log information inside this all. And I can build exactly the same view as this inside App Insights to taking advantage of the app map, which is another place. And we also have many other more observability tools like this. So, for example, I can dive down into this Python application. I can search for the traces here. And then I can look at one of these particular traces, and I can see the call graph here. So you can see the invoke here called onto my Node app new order method here. The total time it took was 5.68 milliseconds calling the way through, which includes all the way through in terms of saving that state. Takes a little bit longer here because this is saving out to Cosmos DB. You'll find that if I actually switch this out for Redis, this goes down to about 2 or 3 milliseconds. So the store time here, you see inside this Node app here, this time it takes to save the state to the Cosmos DB app is the one that kind of is dominating the whole call graph. So this lovely visualization of your data gets given to you for free. Plus Dapr as well has built-in dashboards. this is actually the dashboard for you to be able to see the state of your system services that are running inside your Kubernetes cluster, the overall numbers of services created, the number of services deleted inside here, the number of sidecars that get generated, and also every service itself gets a certificate deployed to it all, because you have secure end-to-end security between your services. And you can see the certificate creation and signing a request deployed to each one of the Dapr sidecars inside here. So this visualization of what's happening inside your dashboard, and we have a similar one like this for your services, provides you a detailed view, as well as actually as a fun little console that we bought here, built here to see just sort of the state of your running applications if you want a little dashboard that we put inside here. So this is all about visualization, seeing that data, and making sure that you're able to diagnose, particularly at deployment time and in production, the metrics of how long a call takes, seeing the call graphs and pulling out the logs inside here. Finally, I think one of the most exciting building blocks that we have as part of this got contributed by the community, and that is how you can get hold of secrets. I don't know how you've tried to kind of pull out a particular secret that you wanted to use inside your application because you wanted to be able to attach to a backend SQL database and have all those credentials, and you know that you should be storing that inside a secure vault rather than putting it in your code or having to build it as part of your CI/CD system. Dapr does all the hard work of being able to authenticate on the behalf of your code to external secret stores, pull down secrets, and give them back to you through a local API call that you can call to a particular My Vault that gets configured to any number of these different secret stores. So you see that we built in Azure Key Vault when we released, but since then, you can do it for HashiCorp Vault, AWS Secrets, Google Secrets Manager, and store all your secrets, including also storing secrets inside the environment itself if you want to store them inside the Kubernetes secret store as well. So this way of getting hold of secrets, we've seen numerous times people just have to build a whole bunch of code themselves to do this all. And in the Azure world, this actually will also take care of pod identity as well if you're running it inside a Kubernetes environment. Talking of what the Kubernetes environment looks like, Dapr will target multiple different environments. Kubernetes, Service Fabric, Docker Swarm as part of them. For now, we've started off on self-hosted on your local machine or running inside sort of VMs and targeting sort of Kubernetes. And so here, as I showed you earlier, these system services take care of when you spin up your application code itself. The sidecar injector injects a sidecar on your behalf. The Sentry service is a super key service because it's a certificate authority, and it provides certificate generation and upgrade across all of the applications that you have running inside, or services you have running inside your environment. So you can do end-to-end security through MTLS all the way through between service 1 calling onto service 2 inside your deployment. So this, the difficulty of securing your code is taken care of for you by the Sentry service. And then the operator takes care of updating and pulling in the various components to make sure your Dapr sidecar is aware of them as they get changed. I showed you how it looks inside a Kubernetes environment and what it looks like. In fact, if I just return back to that here, these are the Kubernetes operators running inside here as that first-class experience. But the point here is that this is just a way to make sure that you can take advantage of Dapr running in that particular environment, and certainly other environments such as IoT Edge and Service Fabric, and these other ones are also sort of part of the roadmap as we go down. But Kubernetes is one that's sort of fairly universal, so it's an easy one to target to begin with, and you get them to deploy inside here. In fact, if you just do, if you look at the services running inside here, if you look at the services, you'll see that for each one of these services that get deployed here, my node application, there's a Dapr sidecar running next to it that I can see here running. So that's how it gets launched and run.
Mark, would you mind if I threw a couple of quick questions at you?
Go for it.
And as a quick aside, we seem to have lost your camera, sir. If you turn that back on at some point. So a question from the channel, which is relevant to what you were just talking about. In terms of calls from app to sidecar, are there plans for any kind of security to be implemented to sort of lock that down?
From app to sidecar. Oh, yes. Well, that's a bit of a debate. Yes, there has been some asks where, if you look at the diagram I had previously, from the app here to this sidecar, can this be secure? Well, this actually depends on the environment you're running in. So, typically inside a Kubernetes environment, inside this pod, this is sort of deemed a secure environment. But we have actually had requests to ask about, can this be secure over here? So we're thinking about it. Yes, it is a little bit more extreme because it does require that something has got into the pod, or whatever the hosting environment is, to be able to attack this channel here, which is a lot harder to do. But it is something that's worth considering. Yes. Okay.
And also, you were showing Visual Studio Code just a second ago, and I noticed that down the bottom of your left-hand bar is the little Dapr hat.
Oh, yes.
Is the Dapr extension that you've not mentioned?
Oh, yes. Okay. Let me switch back here. Let me show you this. Let me see if I can do a demo of this one here. Okay. So what you can do, yes, there's a Dapr extension inside here. A Dapr extension allows you to launch and do debugging locally of your application. So I think I've got this one set up here. This particular one has a launch JSON here that allows me to go into my code. So, for example, inside this, I've got a couple of breakpoints set here. I could actually go and do run, start debugging. And if I do debugging here, it'll launch Dapr locally inside here. And you'll see that I've got, I can hit breakpoints here with Dapr by using this Dapr sidecar. And I can do a full debugging through my application. And what I'm able to do is I'm able to, if I just let this run, this is my application now, it's up and running. So these task.jsons inside here will be able to give me the full debugging experience. I can go into this Dapr sidecar here. I can actually now do an invoke method inside here. So I can actually sort of invoke the order method inside here. And you see there I am. I've called the node invoke method inside here, calling that order method. And now I can do a step through inside this. I can actually step out of that inside here, and you'll see that I'm doing a full debugging experience. So yes, there's a great little plugin inside Visual Studio Code that allows you to do a debugging experience like this, and also take advantage of being able to do gets, posts, and publishes into your application to test them out rather than doing it on the CLI. So yeah, great question. And hopefully there's a little extra demo there I didn't think about.
That was great. Thanks, Mark. And I'll let you get back to your presentation for now, but we've got some more questions that I'll throw at you at the end.
Okay, let's sort of go up a level a little bit and go into what, talk about you as a developer here. So the key thing is I showed you lots of HTTP calls, or you can do gRPC calls, and you can do them at that level. That's like the lowest common denominator. But we've also built language-specific SDKs because we recognize developers like to fit inside their particular language, whether that's Node or Go or Python or whatever. And we've also integrated with a set of frameworks as well on top of that. Things like ASP.NET Core and Spring Boot, and coming on the roadmap soon, hopefully next month, is integration with logic apps and functions. So effectively, you get this layering. You've got Dapr and its building blocks. And then you can engage through HTTP and gRPC APIs. Through a gRPC APIs, we do generated gRPC proto-generated SDKs, which are generated versions from on top of the building block APIs that we have. And then on top of some of those particular ones, we're slowly working through and you could use these SDKs at this level here. So these are perfectly usable SDKs. It's just that they may not be the most beautiful of them because they're generated, but you can go off and use these SDKs at this level as a first-class language experience. However, we've crafted ones that are a little bit nicer for Java and .NET, and all of the other ones are coming along soon. So you have a slightly better experience in terms of some of the types that gets used. And then on top of that, particularly, we've integrated across these, in fact, to provide sort of language integration at that particular level as well. So we're building out application frameworks that integrate on top of these SDKs as well. So you can engage at the lowest level HTTP or take advantage of these SDKs or up to the application frameworks themselves, if that's where you feel that you're most productive. So let me go and show you a couple of demos of what that looks like. First, I wanted to show you, let's just go into an ASP.NET demo and show you first just ASP.NET demo, just without using any of the SDKs, just to give you an idea of what it would look like. So here I have a classic simple ASP.NET app. It's just got a main, and it just creates a local web host running inside it all. Does its startup command. Inside my startup command, here's my startup. I can do classic, bring in various routing and bring in different endpoints. And the way pub sub works is that you have a subscribe endpoint that Dapr calls onto you, and you say, here's the topics I'm interested in listening into. And then you have endpoints inside your ASP.NET application. So here's topic A and here's topic B. And all I do is I get the body of the message out and I read it and send it back to you. Now, I can run and launch this particular application. Let me just go and grab a little script here a moment. I can run this with a Dapr command. So I can do Dapr run, name of my application, app ID. It's going to listen on this particular port, and it's a .NET application. So here I'm going to run this. And once it's up and running, there we go, it's launched. I can bring up another window here. And I can take advantage of Dapr's CLI in order to publish a topic. So I'm going to publish a topic onto topic A, which is this topic A just here. And I can do things like global Azure is awesome. And then I can publish this message here. And this just shows how the simplicity of bringing in pub sub. If I now go back to where my ASP.NET app is running, you'll see here I received a topic A post message from Dapr. I received a message, Global Azure is awesome. And here's the event received. So at the simplest, I could just plug in and take advantage of the HTTP calls like this. But I can go up the stack and I can take advantage instead of a first-class client that we've built for .NET. And so here I have a very simple program, and I'll combine the two in a bit. Here a very simple console application. So it's just a main application. I can pull in a single library here, Dapr client, which is a NuGet library that we publish onto NuGet. And inside Dapr clients, you can actually use Dapr client builder to get hold of a particular client. And now I can take advantage of publishing events or saving state through a first-class API. So here I am. I have my save state that takes my Dapr client, and you'll see now that instead of having me to deal with HTTP methods, I can take advantage of a set of client methods inside here that allow me to save state save state or get state, save state or get state. And now I can really do this through a first-class language experience rather than through a web-like experience. So in this particular case, I've got a widget. I can actually go and run this particular application here. So I'm going to run again, Dapr run. Here's the application. I'm going to run this one locally. I configured this to store into my local Redis store. And you'll see that I called the publish event, saves, and get the data back out. So here I am. You'll see that I published a topic here. So I think it was topic A. You'll see that this conforms to the cloud event specification. The data is inside here is my my Global Azure event. Maybe it was this topic B. Oh, no, okay. The event is somewhere inside here. But as you can see here, here's my test data that I saved inside here, which is my data, which is my little widget I saved and retrieved it all. So now I can just take a first-class language experience if I want to, in order to take advantage of Dapr and putting it in as a client library. I can now sort of combine these two if I want with a local client API, which I have here, this local client with ASP.NET. And if I switch over, I'm going to give some love to Visual Studio now. This is one of our sample applications that we have here now, which is an ASP.NET core application that shows a controller. And just like I showed you before, it has a main function that's launching ASP.NET applications, ASP.NET web endpoints. And inside the startup method here, just like I showed you before, I could take advantage of now a first-class integration at the ASP.NET controller level. So now, as part of a configuration here, we've done a first-class experience where, as part of configure services, I can just add a service here called add Dapr client. So that pulls it in and gives me, by injection, gives me a client class that I can use, a Dapr client class. And now I'm also able to take a look at my routing endpoints here. And inside my routing endpoints here, rather than having to have the publish and subscribe endpoints built inside my application, I can have an ASP.NET experience here where I can say with topic here. And then this is a pub sub message that comes into me that I can activate my code set instead. So I can now bring in publish, have my ASP.NET application be invoked with, I brought a superpower to ASP.NET, because now I can have publish and subscribe events triggering my endpoints here, my ASP.NET endpoints. And then this particular endpoint here, deposit, is an endpoint that's down here. And then inside here, I can take advantage of the client class that I'm using here to save the state into a particular store. So here I'm combining both the client class that I've got here with the routing for pub sub and putting it all together into an ASP.NET experience where I can take advantage of these publishing events. And inside a controller example, if you look at the controller syntax inside here, you add attributes instead inside the controller for the deposit. So this gives you very productive now capabilities that you never had before, long-running stateful ASP.NET applications, ones that can be triggered with events, ones that can retrieve secrets, and everything else is the power of Dapr brought to you. Good. So let me switch back to my slides. And I think I'm on the home run actually just here now. I showed you Dapr SDK clients. I showed you the SDKs. I'm going to finish up just talking a little bit about actors, and then we'll open up for some questions. I really don't quite have time to show you an actor demo, but also as a first-class experience, if you're familiar with the actors that were built into Service Fabric as a concept which allow you to hold state and compute together into a single entity. You can create millions of these things inside your environment. They are turn-based and they have state associated with them. And generally, in your environment, you can have lots of these things running. If they fail, so Dapr takes care of rehosting them into other environments. And these are another powerful way for you to build your applications, particularly if you're doing things like IoT systems with virtual devices or gaming systems, for example. And they're very, very similar to Service Fabric Reliable Access if you use them all. That's what I've had. I've got time for some questions, but we're thrilled that the community has just sort of dived in and really helped us with so many external contributors, many of them MVPs, many of them that we recognize who've helped us over the last few months. The repo is getting close at 6,000 stars. If you love this presentation, please go and star the repo, because that's something that it's actually we're actively watching. And we have a community call that happens every 2 weeks. We're very open. We do fun demos. We dive onto that every week. We bringing out some demos to show. We have one coming up next Tuesday. You can join it by going to Dapr community and coming to ask us anything. We are open to any question in any way. That's me.
Mark, that was great. Thank you very much for that. I've got a couple of questions for you. I'll just remind you again, if it's possible for you to turn your camera on and then we can chat, that would be great. So that was a really interesting session. Dapr's been around for a while now, and its engagement's been really great. It's been pretty meteoric. I was looking at the GitHub repo. You're at version 0.6. A question from the channel, and I know this comes up a lot with customers who are looking to adopt technology and try and decide which ones to pick. When do you think you're going to hit 1.0?
Oh, great question. So that's the primary goal of where we're going at this moment in time. So this is where we are working very, very closely with about between 5 and 10 customers at the moment, and taking Dapr into production. And what that means is that we are getting it into real world deployments, running at scale. They're hardening and testing it all. And so our goal is in the second half of this year is to get it to a stable 1.0 version. So that's the roadmap. So you'll see at the moment that we're doing lots of things about end-to-end testing, perf testing, scale testing. We're doing lots of resilience testing. We have external security orders coming along. So that's where we're taking the direction of the application. Great question. Is my camera working now, by the way?
Yes, it is. Thank you very much. So related to that then, have you seen much engagement from sort of larger organizations who are starting to develop their applications using Dapr?
We have actually, yes. In fact, we have several internal projects that are happening and using Dapr, and we have about coming up to about 10 external companies who are actually taking Dapr into production. They range from things like building intelligent buildings, IoT devices, to a financial transaction application, to telcos integration for building sort of a workflow telco application, line of business applications, and on a range of Node, Java, Go, and .NET, all being the strong languages that they're using inside there. And in fact, we're looking for more. So if you have a project that you'd like to collaborate with us on, we are more than happy to help dive in, do design reviews, because we recognize that that's what we're doing.
Okay, that sounds great. Hopefully our viewers will try and get in touch with you over that one. How should they get in touch if they think they have an appropriate project?
Well, send me an email. My email, you can directly send me an email to, it's on my slide here right at the very beginning. You can send me an email to mfussell@microsoft.com. But you can also dive in on our Gitter channel here. So we have a Gitter channel that you can go and ask questions on. And feel free to just throw a question on here. And on this Gitter channel here, this is very an active community at the moment where we have people who come and ask questions. So this is another place. Either of those will work. Okay.
All the way through your demos there, Mark, you're obviously using containers. The Dapr command line was all Kubernetes. How tightly is Dapr tied to Kubernetes? Do I have to use that as my container orchestrator? Do I even have to use containers at all?
So, a good question. And the answer is, all of the CLI commands were not bound locally to containers or Kubernetes. So my local experience is actually when I deploy it locally, I can run Dapr just simply as a sidecar process. It's not bound to containers. There are a couple of, we require just Docker on your local machine because we happen to deploy Redis there as a simple container for your local development environment. But locally, it all runs as processes. But I want to sort of stress as well that Dapr is not tied to Kubernetes in any way. It's entirely host independent. It can run on other platforms as well. In fact, we're targeting IoT Edge, Azure Stack Edge. You can run it on VMs, and Service Fabric as well will be on that roadmap as well on those PAMs. So it's very important to realize that the code that you take is portable across different platforms. It just requires some level of integration. So for example, the service invocation requires integration to the host platform, but the pub sub doesn't. So you can just run that anywhere. So there's some level of integration that you need to have. But yes, Dapr is not bound to Kubernetes.
Okay. Well, Mark, we're just about up on time, so I'd like to say thank you very much for a really engaging session. Thanks for taking our questions. And best of luck with hitting that 1.0 milestone. We're about to take a break. We'll be back in 5 minutes. And at that point, I'm going to let Izzy take the reins, because we have had several members of the Azure Stack team join the call, as you might have noticed over the past couple of minutes, and they're going to speak to you and to Izzy about what they're doing and they extending the capabilities on the intelligent edge. So go refresh your caffeine, your beverages, grab some food and sugar, and we'll see you back here in 5. Thanks very much.
Good morning, good afternoon, good evening, dobre jutro, dober dan, goedemiddag, goedenavond. It depends where in the world you are calling from, because we truly are a global community today. We have people joining in from all over the planet, as well as attendees and speakers. My name is Isidora Katanic. I'm your virtual host together with Rick today. And we would like to welcome you back to Global Azure 2020, the virtual edition. Make sure you stay active with us on social media under hashtag Global Azure, and don't forget to tweet your mugs under hashtag Global Azure Mug. So we are ready for our next session, which you can see is going to be very exciting. We have the Azure Stack team here with us live on the call. And I will just quickly introduce you to the lineup of fantastic speakers we have joining us today. So we have the incredible Natalia Matskevicius, the head of product management for Azure Stack, of whom I had the honor to meet in person multiple times. And it's really an honor to have you here today, Natalia, so thank you. We have Tiberio Radu, or as we like to call him, TB. We have Javier Fernandez from the Event Hub team. We have Christopher Turner, a great friend of mine, who you might know as the Texan Country Cloud Boy on Twitter. And we're also having a customer on the call today, so we can hear about his experience going through this journey. So the session will be about extending capabilities on the Intelligent Edge. We will hear from the team updates, news on improvements, roadmap info. We will see demos across Azure Stack Hub and Azure Stack Edge. So it's going to be a very excited 45 minutes. Please be active with us in the YouTube chat. You can ask your questions, and at the end of the session, Rick and I will make sure to read out your questions. So, dear Natalia, the stage is all yours.
Thank you so much, Izzy. I'm really honored to be here. So good morning, good afternoon, good evening, everyone. I'm excited to be here to talk about the Azure Stack portfolio, as well as the Intelligent Edge, and so many things that we're doing across this portfolio that are really innovative, and we hope you'll be really excited about. So first, I wanted to talk about just our broader hybrid edge portfolio. If you look at our broader edge portfolio, it starts with a single control plane. So Tibi, if you can go to, well, thank you. Single control plane with Azure lets you extend AI to the edge with devices, as well as Azure Service. Part of that on Azure Services, any infrastructure. That means not just in Azure, but also like AWS or VMware. And with Azure Services, you'll see us continue to add additional services that are containerized and can be deployed anywhere using one single control plane. On the far right, we have Azure IoT. And Azure IoT allows you to do IoT capabilities, things like AI, cognitive service, run machine learning, and advanced analytics for closest to the data. And then the area that I'm most excited about is how you can modernize your data centers with Azure Stack. And a lot of this goes into our Intelligent Edge computing, running data closest to its source, enabling you to run Azure services, whether those are containerized services or full cloud native applications and services in the data center and at the edge. So let's look at the hybrid offerings within the Azure Stack portfolio. Many of you have probably seen our Azure Stack system, which is the Azure Stack Hub. And we've renamed that to Azure Stack Hub because we've expanded our portfolio to include additional offerings in the Azure Stack family so you can consistently build applications and services. And that could be on-premises in a data center where you have completely air-gapped environments, or it could be for edge capabilities that you're running in branch offices or even in very rugged, remote, austere environments. I'm going to go a little bit deeper today. You're going to have a lot of additional context in Azure Stack Edge as well as Azure Stack Hub. So let me start with Azure Stack Edge. Azure Stack Edge, it's a cloud managed appliance. So you can literally buy it from Azure. You can go into the portal and purchase a system that is a first-party system. So it's a Microsoft managed appliance. And here you can run Kubernetes applications, bring that edge compute as well as to that application. In addition, one of the things we're really excited about is the ability to do network data transfer to the cloud. So to take an Azure first party and transfer data to Azure, and in the future, you will also be able to do that to Azure Stack Hub system. Let's go to the next slide, Tibby. And if you look at the Azure Stack Edge, if I go a little bit more deep, Azure Stack Edge managed appliance, you can do things today like running FPGA to actually look at machine learning capabilities and run those data models. You can take things like looking at video feeds and running AI closest to the source and then only transferring data to the public cloud or even at Azure Stack Hub in the future. You can do edge computing. So a lot of this is some of those applications you might need: cognitive services, machine learning, AI capability, all of your workload needs. You can even have custom ones that you can have available. Those custom modules were available as the IoT, but then also what we're bringing to our future is also just virtual machine management support. So you can have VMs available as well as custom Kubernetes applications and services. At Ignite, so announce some additional hardware and form factors. So it's a Azure machine storage gateway transferring Azure data to the cloud, and then in the future to this session, you'll get to see a demo by Christopher, who's going to show you some of the Azure Stack Edge and some of the AI and machine learning capabilities that you can use in vertical. Go to the next slide. At Ignite, we announced some additional form factors for Azure Stack Edge. Did we miss one? Hold on a second. Ignite, we announced additional form factors for Azure Stack Edge. In part, the is more the commercial series. As I mentioned before, abilities on Stack Edge. And these are traditional form factors, 1U devices that you have. What we're adding is NVIDIA T4 GPUs. So you can do additional machine learning and AI capabilities at the edge that we're adding, and we showcased at Ignite. Normally, I'd be able to actually show you the device, but I'm working from home, so I don't have that here. But we have rugged and portable devices. So 2 form factors that are coming in our rugged series. First is a larger rugged offering, which is still the 1U server in a ruggedized case. So you can bring this to harsh or austere environments. Think of this as even in manufacturing or mining capability or other areas where you don't necessarily have data center space. We've even reduced the form factor to a size that it is literally you could fit in a backpack. It's about this size, and that's also ruggedized, and that preview is also coming. So we do see these as really innovative and meeting customer needs to be able to run edge computing no matter where you need that compute available. Next, I wanted to go through Azure Stack Hub. So Azure Stack Hub, many of you have probably been with us on a journey where we announced Azure Stack Hub to bring cloud native capabilities and a completely autonomous cloud to a data center or a location. So this allows you to run completely consistent hybrid cloud capabilities. They can run either connected to Azure or even fully air-gapped from the network. And we continue to innovate and provide additional applications and services for this autonomous cloud. So in most environments, we have web apps, container marketplace. We've been innovating on providing with an AKS engine. We've also, in preview, have many additional services like IoT Hub and Event Hubs, which Javier's going to go through and show you a demo of that. This also gives you consistent application development, as well as the capability to bring marketplace content. So a lot of ISV solutions have marketplace content in Azure that can also be used on Azure Stack Hub. It's a per-built integrated system, so we have it available for many different hardware providers. This gives Azure service with a consistent development paradigm that you can run fully air networks, even for regulatory and data sovereignty environments. So we're seeing this a lot in the government space. We're seeing it in manufacturing and mining, oil and gas, all these manufacturing with IoT coming on board capabilities. We continue to round out additional services. So we're really excited about a lot of the innovation that we're doing and the ability that we will have to even migrate some sort of 2008 images that Tibby is going to go through. So you'll see what you can do from migrating end-of-life Server 2008 and SQL 2008 images onto Azure Stack Hub. You'll also see today's event from Javier, some of the event hubs and the things that we're doing. We have a lot of additional services and even GPU capabilities. So not only can you do edge processing, but you can also train models on an Azure Stack Hub system. So with that, I'm going to hand over to Tibby, and he's going to go through some of the migration opportunities and things that we're doing on Azure Stack Hub. Thanks, everyone.
Thank you, Natalia. Hello, everyone. My name is Tiberiu Radu. I'm a program manager on the Azure Stack team. I focus on IaaS management, migrations, and essentially what you can do with these workloads once you've migrated them on Azure Stack Hub. I gotta find the right screen. As we talk about the migration opportunities, there are various factors which contribute to these migrations. These are triggers coming from things like hardware refreshes or compliance needs or anything like that, but also from things like software end of support. This is one of the programs that was launched in last year, I think in summer last year, where we had SQL 2008 reach their end of support. And with that, there was an extension for using Azure workloads as well as Azure Stack. Meaning if you move those VMs on Azure or Azure Stack, you would essentially get 3 years of free licenses, of free extended support updates, pretty much. So this is a good opportunity for various companies to actually use as a trigger to migrating to the cloud. So the cloud, the transformational process itself has various, like we said, has various triggers for these. Even if there are things like the hardware refresh or the end of support, these are the lift and shift processes themselves, where you essentially take the VMs, you move them on Azure Stack or you move them on Azure, and then you can take advantage of the things enabled by the platform itself. These are things like as simple as an ARM template or things as simple as creating an NSG or RBAC to actually enable those workloads. All the things I'm talking about now, we only have like 10 minutes, so all these things will be listed at the end in a set of links. We have written a number of blogs about this, and we have a series on IaaS and how IaaS enables these features across the platform. As well as there are guidances on how to actually do this migration. Because when you're moving from a traditional virtualization platform to a cloud, if that cloud is on-prem or if that is a public cloud, it's still a cloud. There are certain things you need to take into consideration when you're doing this. So we wrote a number of articles which talk about the things to consider, the questions you should be asking, and the things to take into consideration when you're doing this move itself. This is an important part, though, because as you move to the cloud, you will have the IaaS enabled features. Like I said, things as simple as RBAC or resetting a password on a virtual machine. But there's also opportunities for you to move to a PaaS or a serverless layer as well. So taking more and more advantage of the platform and taking more and more advantage of what's offered from the platform. We kept talking about the traditional virtualization and the cloud. I'm sure everybody knows this, but in a traditional approach, essentially you are managing everything from the networking all the way to the actual application. While when you're talking about an IaaS platform, you have the everything up to the OS itself managed by the vendor, essentially, and then you will need to manage the things on top. So the OS all the way up to the application. As you progress to the platform as a service, everything up to the runtime itself will be managed by the vendor themselves, right? So, and when you talk about a SaaS, of course, everything is managed, so you just consume that application. Now, from an Azure Stack Hub perspective, this is what Azure Stack Hub essentially looks like. You can think of it as a black box, which is provided from the vendor if you want, and it's tested, it's on tried hardware, it's on validated hardware with all the services sort of stitched together and creating this platform that you can take advantage on, even if it's something as simple as an IaaS workload or more complex things like PaaS and building up towards a SaaS-like environment. So from a platform perspective, these are exposed through the portal, and these are something these services are something you will consume. By services, like I said, even something as small as a virtual machine, all the way to things more complicated like app services, or we'll go into details in a few minutes. Now, from an IaaS perspective, Azure Stack at its core is an IaaS platform. And this is not an understatement. What we've seen with our customers, with our existing customers, is the approach is to go with the lift and shift approach and then modernize those applications. That can mean something as easy as creating a ARM template, or something more complex like re-architecting the solution and taking advantage of those PaaS services. So to sort of highlight these things, we came up with a blog series which you can find here. All the links will be in the next slide, I think. The blog series goes through a number of aspects. It starts with what the platform is. The second article talks about the migration process itself, how you should be thinking about the migration, what to consider when you're doing the migration, as well as the third-party vendors that you can use during this migration, because you will need a tool to actually move those workloads and to migrate them. And we'll hear in a second from Mike about their experience with the migration and what they are looking for on this. And but in essence, these are the things enabled from the platform. Like I've said, there are things as easy as adding a disk, all the way to things more complicated like treating your infrastructure as code. Infrastructure as code is an approach where essentially you are describing your entire infrastructure as code. You are building ARM templates, which then will get deployed from the platform itself. So you can apply things like a CI/CD pipeline, for example, for that infrastructure as code. So anytime you add a new disk, you should test what happens and what breaks when you're doing that, right? So of course, we don't have enough time to go through all of these, but I wanted to sort of highlight these links for you. These are the places where you will find more information across building a practice around Azure Stack Hub, and starting with the foundational bits. So the second link in here starts from the slides all the way to the workshops, as well as videos which guide you through all of these things. And then there are other links on building a practice and building an entire infrastructure as code approach if you want. Even if you start with something as easy as a migration, a lift and shift in the context of the OS or anything else, this will be a good place for you to start. To give us a bit about their journey and how they thought about this, I want to invite Mike from Eversource with us. They have actually, they're going through the migration as we speak, and they have quite a few things to share from their end. Thank you. And Mike.
Thanks, Tibby. Appreciate it. So as Tibby said, my name is Mike Viskorski, and let me get my presentation up here really quick. And I work for Eversource Energy, and we're based out of the Northeast. So first, I just wanted to give a little bit of introduction of who Eversource Energy is and who I am. So Eversource Energy is a regulated energy company operating out of the Northeast. We provide electric, gas, and water customers across Connecticut, Massachusetts, and New Hampshire in the United States. As I said, I'm Mike Viskorski. I'm a cloud domain architect with a focus on Azure Public Data Center integration, data center hybrid infrastructure, as well as Azure networking for Eversource. So I'm going to hop right into some of the things that Tibby talked about of why Eversource Energy chose to move forward with Azure Stack Hub. We currently have a decent sized IaaS and PaaS footprint up in the Azure public region, and we really wanted to figure out how we can start standardizing on a single product base. And as we started to learn more about Azure Stack Hub, we found out that we could bring Azure into our data center and start leveraging IaaS and PaaS platforms, more so app service, in our data center, and really starting to standardize on one platform to support. And one of the big gains that we saw with this one platform to support is Microsoft has made the management and the support and update process of the Azure Stack Hub truly one click from an operation perspective. So as Tibby said, it's a kind of black box. We went with Dell for our Azure Stack Hub equipment standpoint, and literally gets installed when we need to upgrade this hardware. I press a button, and literally in one of the updates, it upgraded my entire system from Server 2016 to Server 2019 without me having to do anything other than watch it, and it worked flawlessly, and I did not have one issue. That's different than your standard hypervisor platforms and some other products where you have to do a lot more care and feeding and hand holding. You're going through and walking through an update of that infrastructure. Where Azure Stack Hub, like I said, literally pressed a button and it literally rebuilt my whole hub in the matter of a day or two. So that's really impressive and really simplifies that process. Now, being that we're a regulated industry, we'll never achieve 100% cloud-only footprint. What we like to say here is we're not cloud first, we're cloud right. So we need to figure out what's the right spot for our workloads in relation to cloud. So what Azure Stack Hub does in bringing Azure into our data center is it allows us to bring some of these legacy technologies and legacy platforms, as Tibby stated, like these Server 2008 platforms, up into the Azure environment, specifically now with Azure Stack Hub in our data center. So we are actually starting to move some of our 2008 workloads into Azure Stack Hub, which also is giving us some of that extended support in security and patch support for the next 3 years, which helps from a cost saving and from a security perspective. Around migration and modernization, as Tibby spoke about, you have to migrate your workloads onto Azure Stack Hub. So like we did with our Azure public environment, we're also going with a lift and shift model to our Azure Stack Hub environment. That's really the easiest way for us to migrate and show the value of Azure Stack Hub with the least amount of risk. So initially, we're going to look at migrating our Server 2008, Server 2012, and Server 2016 IaaS workloads across a dev, test, and prod environment into the Azure Stack Hub. Now we have enabled and installed the app service as resource provider in Azure Stack Hub, and we will look to in the future to try to start life cycling some of these IaaS web applications into PaaS-based applications to leverage across Azure Stack Hub and Azure Public. We are leveraging a third-party product called Beam to help us with our migrations from our existing hypervisor on-prem into Azure Stack Hub. Now, around the modernization, this is, I think, one of the best things that we can prove on how standardizing on Azure as a platform is really going to help us modernize our data center, whether it be up in the public cloud space or in our on-premise data with Azure Stack Hub. some of the cool things that we've been able to leverage that have helped us modernize is Azure automation. So we're able to leverage Azure automation accounts, and Azure Stack Hub supports hybrid worker servers to push automation from Azure Public down to Azure Stack Hub. So one of the things that we wanted to do, for example, was be able to shut servers down on a nightly basis in Azure Stack Hub to avoid incurring costs when we don't need to use some of our dev and test workloads. Now, even though that feature isn't natively available in Azure Stack Hub, we're able to leverage existing Azure automation accounts that we have in Azure Public, existing runbooks with just a little bit of modification, and push those runbooks to our hybrid worker, and we're able to auto shut down and auto power up our servers in Azure Stack Hub, just like we do in Azure Public. So really standardizing across one type of automation platform, one type of automation process across our public and on-prem data centers. And as Tibby talked about earlier from ARM template deployment, we're also able to leverage some of our existing ARM templates to deploy VMs via PowerShell directly into Azure Stack Hub. And now with the release of Azure Stack Update 2002, there's a preview for the Azure AZ modules, which is very exciting for us because most build and template deployment for Azure. And now we're going to be looking to standardize not only our also our build process across our Azure Public environment and Azure Stack Hub. So really what this is doing is we're able to modernize our data center on-prem and try to keep it we're doing in Azure Public, and standardizing our automation, cutting down on support, cutting down on overhead. And I'll be honest, I am very excited to see what Azure Stack Hub can do now and in the future. So just a little story of what Azure Stack Hub for. Thank you, guys.
Thank you very much, Mike. Some of these services that, as Mike described, some of these services are able to sort of run across Azure as well as Azure Stack Hub. So you have a hybrid approach. But in some cases, there is a need to have the PaaS service itself running on Azure Stack Hub. So Javier will join us next to talk about the running event hubs on Azure Stack and what that means. And Javier, you can share your screen, please.
Absolutely. So welcome, everyone. I'm the PM for Azure Messaging, and we are behind the messaging services on Azure Stack Hub, like Event Hub, Service Bus, Event Grid, and Relay. We recently released Event Hubs on Azure Stack Hub as a preview, and I'm going to be touching on that. But also, I want to share case, event hubs, it is there is event hub on Azure and event hub on Azure Stack Hub. It is exactly the same operational experience, the same APIs, the same SDKs, ARM templates, PowerShell support. So you don't. That is commonizing the way that you work with the PaaS is a great advantage. And this is touches on the same thing, the same UX and API. So what you see here side by side is an user experience, graphical user interface for creating an event hub cluster. On the left is on Azure Stack Hub. On the right is on Azure's event hubs. You see, they are the same. The only variation is when it makes sense. So there's some pricing tiers that on Stack Hub on Azure it applies. On Stack Hub is really is your box. You also 10 cores. You need to know, being mindful of when you are deploying a cluster, how many cores you are going to consume. On Azure, a user doesn't care about that. Is us who are going to be ponying up the cores. So that doesn't exist, but it's basically the same experience. Also, something this is a benefit is avoid expenses for managing licensed software. When we created event hubs, there are a lot of a software that goes into that with different types of licenses. Even open source, we use open source in our products. Managing all that, you don't need to worry about that. The provider of the PaaS service needs to do that. And you just manage probably at most the PaaS service license, just one, but not the potentially tens or hundreds of licenses. Plus a PaaS service, event hubs, and you can see the letters, the messaging. Event hub is a streaming engine. However, it can be also used for event-driven architectures. And so those are the main use cases. So if you want to deploy modern applications, event-driven with event sourcing patterns, data, event stored, event hubs is the kind of a message broker that you can use on the Stack Hub. If you are need some typical streaming applications, for example. You want to analyze the sentiment of tweets, and event hubs on the Stack Hub can ingest millions of tweets per second, many megabytes per second, 100 megabytes per second and that is with the smallest cluster size. So it has a big capacity for ingestion and for egress. Also similar. It's actually more. So in this case, on premises, on your Stack Hub, on the left-hand side, you ingest that through event hubs, and you can have tweets being processed with some sentiment analysis model, and then results put in on storage, or results aggregated data can be sent to Azure for further processing and storage visualization. So one interesting thing is that event hubs support the Kafka protocol. So if you decide you want to use open source software, the cloud native application, and you don't want to be using even our SDKs, the Event Hub SDK, you can use the Kafka SDKs, and because we have the Kafka protocol support. So you don't need to worry about creating the clusters for Kafka and maintaining that. We do it for you. So that is one thing that is a great advantage. Okay, so a very quick demo of what is event hubs. What you see here is the Azure Stack Hub. This is the dashboard Stack Hub, and it is exactly the same, or very, very similar to Azure. This feels like Azure is really your private cloud on your Stack Hub. And I have created some resources Yeah, among them is an Event Hub cluster. So we'll go into that. An Event Hub cluster, you can create a namespace that is like a container of things in Event Hubs. And what are those things? So there are Event Hubs. And we're going to go there to one namespace that I already have created. And we go Event Hubs. The Event Hubs are the entities, the things in Event Hub that contain the events. That is going to be the ingested events are going to go into this event. And I have created a very simple application just to showcase that is a trade book order simulation in which we're bidding for stocks. I have started the consumer that is in blue, you can see, and it's ready to receive events. Now we need to push those events, and we're going to generate JSON bits objects, and we're sending, and what you're seeing here, switching me consumer. This is a consumer, and the green one is the publisher. And we have finished. So we just sent 2,000 events, and the consumer already consumed those. So this is just one simple example. Obviously, in a real life application is much more complex than that, but I just wanted to showcase that. Another thing that I want to show you is the Event Hubs, Azure Stack Hub has an admin experience. So what you saw until now is the user experience, the developer experience. This is the administrator experience. You see your alerts related to the Event Hubs that you have, how many Event Hubs cluster you have created. In this case, I have one. And then so there is some quota experience in which is a way for you to limit the consumption of resources by any given service, any given pass, in this case, Event Hubs. Right now is just 10 cores, which is the minimal cluster size that we are limiting. We're defining this quota that is applicable for users to up to that limit. So that is basically my demo. I hope you have learned something. And with that, Chris Turner is going to be start a transition to Chris Turner. He's going to be talking about Azure Stack Edge, Azure Stack Hub, and other devices to collect data.
Thanks, Javier. Can you see my screen, hopefully? Can you hear me? Can you hear me?
Yes, we do. Yes, we do.
Okay. I just want to thank Javier. So my demo today, I'm going to be showing how to develop and deploy custom IoT. Sorry about this. I'm new to PowerPoint. So my demo today, I'm going to be showing how to develop some custom IoT modules that will support our applications. Using these IoT solutions, we could transfer the data from Azure Stack Edge for advanced deployment. For example, we could scrub images first, remove GPS information and other private data that you don't want on moving it up to your storage. This solution is also going to take advantage of cognitive services like Azure Custom Vision, all from the edge, moving the data before moving to either Azure or Azure Stack Hub. So this is the architecture design in a simple night. I have my development machine. Where I have VS code running. And I have Dapr running. We're going to be taking advantage of several services in Azure Cloud. For instance, Azure Container Registry and IoT Hub. We are going to take advantage of the custom vision service, but we're actually going to bring that down as a module and run that and deploy that over to our IoT Edge device, which our IoT Edge device is Azure Stack Edge. We'll have 4 modules that we'll deploy today, which I'm going to go ahead and kick that off now. Give me 1 second. So I'm going to pop over to Visual Studio Code, and I'm going to actually deploy. Actually, I'm going to start the build, and I'm going to actually start the push of these images now because it's going to take. It might take some time, and I want to make sure I finish before the demo's over. So while these images are being built, they're going to be then pushed up to ACR, and from there we could actually deploy them to our IoT Edge devices, which in our case is Azure Stack Edge. The modules that we're going to be using, that I'm building today, are 3 simple modules. The first one is a file copy module. It's a C# module, and basically this module it allows the IoT Edge module to move files in Azure Stack Edge from different shares and then out to different storage accounts. The second module we're building is the capture image module. This module is basically a simulation. Normally we have like live feeds coming in of video feeds of various things like traffic or parking garages, or you have some kind of solution where images are constantly being fed. But for this demo, all I'm doing is a simple image of a sheep and this is Spaz, the sheep, and this is Kevin, the lamb. And what this is going to do, this camera capture module is end up going to push this image as if it was a live stream to my classifier module. The classifier module is based off of custom vision that I'm going to show you in a second. And that classifier module is going to hopefully identify that image that is a sheep. So I'm going to switch over to the custom vision. This is actually in the cloud right now. And this is how you're going to train this module, this classifier. So I created a project called Edge Sheep Classifier, and I've uploaded a lot of images and different images from stock images, and some of these images are my images of my donkeys and cows and sheep, and we tag them either sheep, cows, donkeys, etc., and we train it. We train this by and the more you train it, the smarter the service is going to be. And then at one point, once we're done training, we're going to export this back down to our development box, and then we're going to build a module that we could then deploy to our edge, and then everything is actually done on the edge and not in the cloud. What I'm going to do is kind of an example of what we're going to expect on the edge, but this is actually being done right now within the actual service in the cloud. So we're going to just pop in an image, and right now the intelligence says that yes, this is 99% chance that this is going to be a sheep. So that's a good thing, right? We know that it's a sheep. That's great. So now we've exported this and we moved it back down to our development machine, and we're creating. We're going to create the modules, as I said. We've already built them out. I've already kind of cheated and have actually had the modules built and have the data already deployed to my ACR, because that would have taken about 10 or 15 minutes. So the next step that I'm going to take is I'm actually going to deploy all these modules as one solution to my Azure Stack Edge device. I've already created my deployment manifest. So all I need to do is actually deploy my deployment manifest. And I could do this in various ways. I could do this from Visio Code. I could go to the portal and I could manually import these modules one at a time. But to be honest, this is probably the easiest way and the fastest way. I'm only going to do a single device. I only have one Azure Stack Edge. But let's say in a solution where I had 1,000 edges, I owned a whole bunch of oil. I was an oil company, and I had edges spread out across the country. And I needed to get this module deployed. I would actually create the deployment at scale. That way I could deploy across to multiple things over time. So I'm going to do a single device. I'm going to pick my edge, and then deployment is successful. So at this point, it's going to take a few minutes. I'm going to keep talking and hopefully entertain you guys. But I'm also going to show through Azure PowerShell. Oh, happy birthday, Thomas. You like that, right?
That was so cute.
So I'm going to just check that my containers are running now on my edge and see how long they've been up. A few seconds of these. So they're all running okay. And I could also check in IoT Hub. IoT Hub is where we're going to manage all these modules that are running on our IoT, our Azure Stack Edge. So as you can see, we have the 4 modules now running. We have the log spout is a third party, is a solution from a Microsoft employee who, with this, it actually ingests the logs from the containers and ingests them up to log analytics. So that way we could get a better view and a single view of all the errors if we had errors. Here's our file copy monitor. Everything has been deployed. Everything is reporting in, and everything is running successfully. If we wanted to get deeper and into some of these things. We get like the classifier, and we could actually make sure that wrong example. Make sure that some of the environmental options actually match what we're supposed to match. This is what we want. This is what's reporting, so we know that exactly everything is working fine and handy. So now that I've talked to you about we kind of scanned through the modules really fast, and we kind of scanned through how to deploy these modules, and now we kind of want to go through and see if this module actually was successful. If this was actually a successful demo, and it actually could identify if this was a sheep or not, right? And I want to give you a quick 1 minute roundup of why this is kind of important. In my solution, I'm gonna talk about my area. I live on a small farm in Texas. It's not very big. It's 14 acres, but let's make this scale. Let's make this a huge corporate ranch, corporate farm, and they need to be able to monitor field health. They need to be able to monitor their livestock and stuff. For me, I'm playing with this. It's kind of a thing that I could go out. I could take my drone. I could scan all 4 of my pastures. I could bring back that data, those images. I could tell where my sheep are. I could tell where my cows are, where my donkeys are. I could actually ingest all that stuff into a tool, another Azure service called Azure Farm Beats. And I could manage the health of my crops and my farm, and I could know which pasture is the most healthiest for my cows to move to next, and then my sheep to follow. So all this stuff kind of comes together as one big solution that is very, very, very valuable to solutions like farmers and ranchers, and then we could also talk about oil industry and all that other stuff. So the deployment, so let me get to my change lot there. Okay, so we're done. Let's go over to our. We've got the modules running. I want to make sure that that we're going to be able to see the results. So I'm running a quick query, and what I'm going to be looking for, and sorry for being so small here, we're going to look for a classifier. As you can see, the classifier is cropping the image. It's got the image from the camera capture module, has sent the image over to my classifier. Now I'm going to look for a message that tells me that the classifier has identified the object and approve that this either works or. So here's one here. Let's see what it does. So this one here is basically telling me that it predicts that it's a probability that it's a cow. So something's not right? So I got to go back and a higher probability that it's a cow versus the donkey but it does have a high probability that it thinks it's sheep too. So just to give you so what I need to do is actually go back into my classifier and train it more, give it more images, give it various images of more donkeys and cows and sheep, and the smarter that classifier is, the better the prediction is going to be. So at the end of the day, at least it knows that it's either a donkey, cow, or sheep, right? Which is moving forward. I mean, this is all pretty cool technology for me. We have the solution developed, and another side, I'm going to go back to the file copy solution real fast before I end this. The file copy solution that I created assists people like myself, or people who are out in the remote with very, very limited bandwidth. So I have these big images, these big videos from my drone, and these images that are coming in, and I'm storing them on an SMB share within my Microsoft Edge, my Azure Stack Edge, and I have a couple of shares with that file copy. That file copy is going to assist in, based off triggers, anytime anything's written to my local share on my edge, it's going to replicate. It's going to move it over to my cloud share on my edge, and then from that, it's going to slowly sync up to a storage account, either on Azure Stack Hub or Azure, depending on where you want that target to be. All based off triggers. And then for me, I have very limited bandwidth out here, so I have some bandwidth controls. So during the day when I'm working and I'm moving images or something like that, my kids aren't going to yell at me because they can't stream or they can't, all the kids stuff that they do. So in a nutshell, that's my demo on sheep or not the sheep, as I call it. And I will pass it on.
Wonderful. Thank you so much. On time. You're almost Swiss, Chris. That's very very punctual.
Thank you.
So thank you, everyone. We do have questions coming in, which I would like to ask you. We have a couple more minutes on the show, and to start with you, Natalia, is the ARC model the future for an increasing amount of Azure services on-prem, and how does it fit with Stack Hub?
Thanks for the question. Oh, let me put my video back on.
Yeah,
there we go. So ARC and Azure Stack and the Azure Stack family are actually really complementary. If you look at ARC has the capability, so it's for some containerized services to be available. So we are seeing a trend for many customers to start using containerized services, but there still is a need to run full PaaS services and to be able to run in environments where you need full cloud capability. So that entirely consistent development experience that we saw with Eversource. So if you look at the Azure Stack family and the edge computing that we're doing, Azure Stack Edge gives you some of that computing closest to its source. We can actually create an entire offline, disconnected ecosystem with Azure Stack Hub and Azure Stack Edge that can run fully air-gapped from the network as well. With Azure Stack Hub, you actually have the control plane on premises, so it allows you to run services like event hubs, and we've got IoT Hub in preview. We've got things like blogs, tables, queues, and the AKS engine coming on board. So there's a lot more robust functionality because you have the full cloud control plane. But ARC gives you that capability to run a lot of those containerized services wherever you need to, regardless if it's in Azure, another public cloud, different infrastructure, or even on HCI. We didn't talk about Azure Stack HCI, but even on Azure Stack HCI. So I really view them as very complementary. You'll be able to run the ARC services on Azure Stack Hub as well.
Okay. Thank you very much for answering our community question. Then I have the next one for you, Tibi. There's still some differences between Azure Stack Hub and Azure Cloud. Some are expected, like the lag in resource provider API versions. Other are more sharp-edged, like Azure Stack PowerShell. What does the roadmap look like for addressing some of the paper cuts that can hinder development of solutions running across both Azure and Stack Hub?
That is a complicated question. The short answer to this is we are working on bringing more and more capabilities across the Azure Stack Hub itself, be that from the PowerShell modules all the way to actual services which are running on top of Azure Stack Hub, right? Consistency is the one of the key points for Azure Stack Hub. So having a cloud running on premises, essentially. So things like the API versions and these improvements are going to follow as well. So with every update, you're going to see more and more of these features sort of making their way in.
Okay. Thank you, TB. Chris, the next one we have for you. Were those farm animals yours? No, I'm just kidding. That's not the question, but I do want to know.
Yeah, most of those images were my farm animals. Okay. The first few that you saw in the training were stock because I needed to get more of it. So it was all those. I have a lot of sheep and a lot of cows and a lot of donkeys.
Yeah. Okay, so thanks for sharing those. So the real question we got is the rugged form factor for Stack Edge or a new offering. How are customers using those devices, and what other challenges come with solutions that need that kind of bulletproof equipment?
Is that for me?
Yes.
Oh boy, that's a good question. I know. For example, we might have one of the customers that TV has on us now is an energy company. So we have energy companies that are spread throughout the country that may need some of devices at the edge that are in these small rural co-ops. So these edge devices would sit at these small rural co-ops and be able to either report back data to either Azure or on Azure Stack Hub at a larger facility, especially when it comes to regulatory and things from government regulatory and stuff. So these things, I would see energy companies as a big use case. Oil industry, of course, when you're out these rigs and you have all this imaging that needs to be processed there at the edge, that's another use case as well.
Okay.
TV might be able to.
I have a little bit more context there. If you look at with Azure Stack Edge, it's really about doing processing closest to its source. So, Christopher had a great demo of looking at his custom vision modules and doing AI machine learning. As you get to the ruggedized form factors, there are so many places where you get to, they don't necessarily have full data center capabilities. So like you mentioned, Christopher, there's oil and gas. If you look at on oil rigs or some of those locations where could be out very remote locations, there's other like manufacturing, if you've got mining, if you're in a mine shaft, there is a need to do some processing of data. If they might want to look at all IoT and sensors from everything from the conveyor belt, do some on some of the things they're mining. There's even healthcare, getting into some healthcare locations are actually in really remote locations. So you might need to have those ruggedized form factors there. So we're seeing it across a multitude of different industries and verticals, from retail to manufacturing to mining to oil and gas to farming. But those ruggedized form factors allow you to bring the processing in places that you normally would not be able to because of either network latency, or you could have the harsh environments from a temperature perspective to just even locations where you don't have full data center capabilities.
Thank you so much for adding the answer to that question. So if we still have, we have still Mike on the call. So we have a question for you. As a real customer, how have you found the experience of deploying, managing, and maintaining Azure Stack Hub? And how do you present the service to your internal users? Is it self-service or is it more managed?
Ooh, that's a good question. So the one thing I can say that we have learned is we're kind of now the Azure administrators. So when you're leveraging Azure Public, you're really relying on Microsoft to kind of be your Azure administrator. So I will say a little bit of learning curve is just really trying to understand how you want to lay out your Azure Stack Hub subscription and really understanding how you want to leverage it. That probably was one of the, I wouldn't say it was a challenge. It was an amazing learning experience, right? And I'll be honest, we couldn't have done this without Microsoft. I mean, people like Tibby and my global black belt, Dwayne, they were with us like hand in hand. I even got to speak with Natalia at Ignite to understand and have them help understand some of the challenges we were facing, or just, some areas we needed help on, and they helped. But really, it was just understanding that we're the Azure administrator now. You're responsible for patching it, looking at the resources, making sure that you understand how your Azure Stack Hub is performing. And that's probably the best way that I can answer that question.
Yeah. Awesome. Thank you. Thank you, Mike.
Just as a quick shameless plug, the learnings and the things to sort of ramp up. If you look at the links that I showed, all of those will go into details on how to do that and how to raise your operator muscle if you want.
Thank you, TV. So with that, we have come to an end of this session. I really want to thank all of you for making time to be here today with us for the Global Azure Virtual 2020 edition. I truly hope you all stay healthy, you all stay safe, and that soon enough we will be seeing each other again in person. So thank you to the team, and Rick and I will continue to our wrap up. Are you still there, Rick?
I am indeed. Sorry, I'm just refreshing browsers. I've been caught on the hop because I was looking at how many sessions we've got, and the number went up before my very eyes.
It did. It absolutely did. Yeah. So maybe this is a good momentum for us to show what other community sessions we have coming up for Global Azure Virtual, because we might be finished with our feature track for tonight. But that does not mean that it's the end of Global Azure, as we do have a truly global community that is still presenting sessions and sharing their knowledge with you. So Rick, if you can quickly show us where do we find what's happening next.
I can indeed show you that. So I've got my screen up now. As you can see, 313 sessions, 202 speakers. I'm sure that's going to stop going up at some point, right? But it might be the end of tomorrow before it does. If you want to find out what's going on, hit our website, virtual.globalazure.net. And if you go to worldwide sessions, you will find a list which we are helpfully trimming. So we start the list at sessions that are going on now or haven't started yet. We present them to you in your time zone based on your browser settings. And all you have to do if you find a session you like is hit that big yellow join stream button, and you'll be teleported by the joys of technology to whatever the speaker is using to present their session.
Awesome.
Now, obviously, when those sessions are done, it's up to the speaker to make them available as recordings. Some of the speakers are doing that, some of the speakers aren't. We encourage the speakers to tweet out with the Global Azure hashtag to let our viewers know where they can find them.
Yeah.
I also want to call out Carl. Mr. Oates has been locked in our back room. He's not allowed to eat. He is diligently trying to edit our recordings and get the sessions as separate videos onto YouTube. So he's already done that for yesterday's sessions. Given that it took him overnight and sort of into this afternoon, I suspect that if you come back next sort of tomorrow afternoon, tomorrow evening, that will appear. Somebody's just asked me to zoom in. There we go. I shall zoom in and show you the YouTube page with those individual sessions with lots of pictures of me with a bow tie. Quickly moving on then. Right. As we like coming back to this one, we do have our Global Azure mug. What you might have noticed was in the chat channel for that Azure Stack Hub session, effectively the Stack, the data center MVPs were out in force chatting with each other. Lisa at the Edge arrived and tweeted her mug just before she joined the chat, which is one that I particularly like. Because it's a witch theme mug and it says "Have a bewitching day." Please do keep those photos coming in. It gives us something interesting calling out, and it sort of gives Izzy and I something to smile at while we're prepping for the sessions. And on the subject of sessions, Izzy, do you want to talk about what we're going to be doing tomorrow?
Yeah, so if you can quickly well, actually, we don't need to show the agenda. So what we're going to do tomorrow is Rick and I will look back at the highlights of Global Azure Virtual 2020. So we will shine the light on communities worldwide because there's literally hundreds of people who in the past couple of days, as well as tomorrow, are putting time and effort in putting community tracks together, country tracks in Spain, UK, Ireland, Germany, all over the world. So we will show you what's going to happen tomorrow. Rick and I will also look back at the highlights, fun stuff we came across on social media. So if you want to just have a relaxing Saturday tomorrow and look back with us, we hope to see you. And with that, I would like to end for today. But before we do so, I do want to thank the global staff. We have David from Spain, Carl in Finland, Alex in Romania, who are both actually also the guys in the green room today. Martin in Australia, Magnus in Sweden, Sjoukje in the Netherlands, and Wesley in Belgium. So with that, Rick, I think we're finished for today. It was a jam-packed feature track, and we're looking forward to seeing you tomorrow.
Absolutely. See you tomorrow, everybody.
Ciao.